You're about to learn the Python programming language from scratch. You'll learn everything from setting up your system to program with Python to working with APIs. Bobby Stearman from Dig Coding teaches this course.
Hi everyone, I'm Bobby Stearman from Dig Coding, and this is my Python course for beginners. So if you're looking to learn Python or polish up on some skills that you've already got, then you are in the right place. Because in this course, we'll be covering topics such as setting up our system to use Python. We'll be looking at numbers, strings, data types, control flows, classes, and all the fundamental things that sit in between. And before we close off the course, we'll then use those newfound Python skills to write some Python programs. But before we jump into it, I'd just like to say a big thank you to the guys at freeCodeCamp for publishing this course. You guys are fantastic. You're doing an outstanding job. Keep up the good work, and also keep that content coming that is absolutely free. So without further ado, let's jump straight into it. So you can see here that I'm on Python's main website. This is python.org. So this course has been designed around their own documentation. I've extrapolated out the parts that I feel are the fundamentals for you as a beginner, but we will be becoming familiar with their site because, like I say, I've referenced the documentation quite a lot. So if you visit python.org, hover over downloads on the nav bar, you can see here it's giving me the option to download 3.10.2. That's their latest and greatest stable version of Python as of the time of recording this video. So if I click that, that will download an installer. And while it's downloading, I will say that as you become better at Python and you become a freelancer or a software engineer, then you will start working on projects that may have been built some time ago, and in which case you may need an older version of Python on your machine. To do that, hover over your machine type on the left-hand side and click. That will take you through to a different page, and you have all of the different releases that you can download. So for instance, if I wanted to download 3.9.10, I could click this here and it will download the installer, and I could go about and just install it in the same way as we are now about to for 3.10.2. That's a little bit more advanced than beginner, but I thought it'd be worthwhile just noting it down. So the installer is here and ready. Let's open that. Okay, so it's given me the option, let me just zoom in a little bit there. You can see that a little bit better. So it's giving me the option to install now. Now you can click that and it will go ahead and it'll install Python in that path. I don't find that very intuitive. I like to keep Python in my own path of choice, because if I want to download more versions, I know exactly where they are and I can just flick between them as and when necessary. So we're going to go with custom install, and we are also going to click the add Python 3.10 to path, because if you're using, let's say, a web framework such as Django will need to look in your environment variables in your path to understand where Python is on your machine. So it's important we click that. Okay, let's zoom out quick. So we will click that. Click on customize, and you can see we've got a whole bunch of things ticked. Just keep them ticked. Okay, this is the first install that you've done, so let's get the documentation. Let's get a package manager called pip. We'll be using that later on in the course, so keep that ticked. Okay, and keep everything else ticked for now. Click next, and then we've got, I'll zoom in again. We've got a few other options here. Just keep it as is. You can see that the fourth one down says add Python to environment variables. That is important. We'll do that. Okay. So all we need to do is click on browse and change the customized install location. So I'll go ahead and do that. And I like to keep my Python versions in my PC, C drive. And in here, I will create a directory called Python. It doesn't know what to contain. Right. Okay. We've already got one called Python, have we? We have. Okay, great. We will then go in there and create a new folder, and we'll call this Python 3.10.2. Click enter. So if I was to install Python 3.9.7, I would create a file called 3.9.7, and I would install all of the Python packages and files and configurations in that directory. So it keeps it all in its own little container, so you can keep flicking between them. Okay, that's why I do it that way. So we click that, click OK, and you can see now where it says customize install location, it's now changed to Python 3.1.02. Okay, now we want to click install. There we go. It shouldn't take more than a few seconds, but that's now going ahead and it's fetching and installing all of the Python bits and bobs and adding it to the directory that we just created. and to test to make sure that it is on our machine, present, correct, and working as expected, we now need to fire up what's called a command prompt on Windows. Now it's called a terminal on Mac, but you fire it up on Windows by going to the search bar and just type in COM and it'll come up with command prompt. Mine looks a little bit different to what yours would because I've changed the settings. Yours would probably be black, but all you need to do is type Python. You put Python 3 or 3.10 if you're on Mac or Unix, and you put -- version. Okay, actually, because we've got the py.exe file installed from this install, we can actually reference on a Windows machine Python with py, and that should still give us Python 3.10.2. You can see that, there you go. Happy days. So we've now installed Python on our machine. We're now ready to start looking at the interpreter. We'll then start looking at things like text editors and IDEs and things like that. So let's call it a day with this video, and I'll be seeing you in the next video. So I'm on a Windows machine, so I'm using a command prompt. So if you are on a Unix, Mac or Linux, then you use a different command to me when firing up the interpreter, or using just general Python commands. You'd use Python 3.10. Now I use Python or py. The reason I know I use the command py is because this paragraph here, I installed py.exe launcher in the last video I put together, which we use to install Python on our machine. So when I'm on my command prompt and I'm typing things such as py -- version, you would put Python 3.10 -- version to do exactly the same thing. Oh, typo there, but you see what I'm saying. Okay, so let's fire up the interpreter with py. This is telling me that the interpreter is open and in interactive mode. That's what these three greater than symbols are telling me, saying, give me some code, I want to do something with it. But before I type into it, let's understand what the interpreter is doing. So as I type Python code into this interpreter, it's translating it into a universal language called binary. Binary is ones and zeros, yeah, and like this. Difficult to read, you can understand. But this is the programming language that software engineers used to use back in the day when writing programs. Thousands and thousands and thousands of lines of ones and zeros. Joe Average could not just sit on a seat and start coding. It was a pain in the ass. Okay, so, and it wasn't very scalable. So from binary, the assembly language was put together. And this kind of streamlined binary, it allowed you to use much more easier to understand commands to do the same thing. But assembly languages weren't transferable between machines. So my Windows assembly language didn't work on a different operating system. Okay, so then high level languages were designed, okay, and this took the assembly language to the next level. This allowed programmers to write code in a humanized way, in an elegant way, to ascend and then translate it to binary. Okay, so that's what. So these high-level languages, PHP, C++, you've got Java, and of course you've got Python, right? So these languages allow us to code in an elegant way, and then things like the interpreter will then translate that into binary code so our machines know what you're trying to do. Now, I hope I didn't just butcher that explanation, but I'll just try to break it down what the interpreter is actually doing, because when I started, I didn't get that explanation. I just wondered what the hell I was doing. I just started typing away and it magically done something in the background. So I hope now you understand what it is and how it works. But before I close this video off, let's just fire in some code and just see it working. So I can just put a simple 1 + 1, so integer plus integer, in this case 1 + 1. If I press enter, it will then run that command, and the result is 2. So we can go 10 multiplied by 6, so we can use the multiplication operator, which in this case is a star. Press enter, and it spits out 60. So that is the interpreter, okay? All it's doing, it is taking our code, in this case Python, and it's just translating it so that your machine can do something with it. Okay, so let's close this video off. In the next video, we will start looking at text editors and IDEs. So thanks for watching. I'll see you in the next video. Bye-bye. Okay, so my browser's open on Microsoft.com on their Visual Studio Code page because we will be installing VS Code in today's video. VS Code is a text editor. Now, we use text editors because in the interpreter, we can easily write single lines of code, we can run scripts, but it doesn't really help us with things like syntax errors and debugging. That's where text editors come into it. And also they will help us as a developer manage things like directory trees and hundreds of files. Okay, that's why we use text editors. They're apps that we can install that help us just do our day-to-day job. Now, IDEs, which are integrated development environments, take text editors to the next level. They do everything that a text editor can do, but with all the bells and whistles. So they help you with things like debugging and deployment, okay? I will be installing a text editor called VS Code because it behaves like an IDE because it has things called extensions, and it's fantastic. And in fact, the reason I'm installing VS Code is because on their own website, they've got a tool here that helps you decide what's best for you based on what you do. Okay, so under the languages, platforms, and workflows, you can click the machine you're using. Then the languages, platforms, and workflows, you can click, in my case, desktop, Python, JavaScript. And it's telling me that the right job for what I do, or sorry, the right app for my job is download Visual Studio Code. So let's go ahead and do that. It will download the installer, it will redirect us first, download an installer. And then if we open that, it'll open up the installer. I will zoom in because it's quite small on my screen here. Okay, so it's asking us to read the T's and C's. Please do that. It's always worth doing that. I've already read them, so I'm going to go ahead and click the I accept the agreement. Click next. It will then ask you where you want VS Code to be saved. I'm going to go ahead and just keep it with the default. It then asks you to, select start menu folder. Just keep that as next, it's fine. Then it's giving you some extra options. One of them is quite important. It's telling you to add it to your path. So same as installing Python, let's get this added to our path and environment variables so that it's accessible and we know exactly where it is on our machine. And then if we click next, it will summarize and we can then click install. Should only take a minute or two, but it's now installing all of the files and all of the configurations in the path that it suggested. When it's done, it asks us if we want to launch VS Code. We will keep that ticked and click finish. And in a future video, I'll show you how to open VS Code in a certain directory as and when necessary. So I already had an instance of VS Code on my machine and it's opened up in the directory, which is going to be the cheat sheet for this course. And you can see that it's got all of the different topics that we'll be going through. But this is VS Code, okay? So if I just zoom in a little bit, there we go. We've got an Explorer here. We don't necessarily need that open. It doesn't really matter. So we've got an Explorer tab or panel. We've got a panel here that we can actually write straight into. So if I open up a new file here and just put hello with an extension py because that's a Python file, that'll open this up and I can write straight into it. Okay? But what is beautiful about VS Code is we can install an extension that will help us with syntax errors. Click extensions on the left, type in Python, and it'll give you a whole bunch of Python extensions. Now I've got this one installed. It's called Python and it's been installed by over 50 million people. Actually, I looked at this the other day and it was 49.5 million. So there's a lot of people installing this extension. So not that, you got to assume that 50 million people can't be wrong, right? So it's good. It's going to help you with syntax errors. Get it installed or select another one and get that installed on your VS Code instance and it will help you with syntax. Let's go back into the panel here. And also what's good about VS Code is got a terminal built in. So where I've got my command prompt here, let me close that down. I would open up a terminal. Mine defaults to CMD because I've changed the settings. Yours might be PowerShell, but you can select the type with this pull down list, click command prompt, and then you can simply put PY, happy days. Now I can type straight into here, 1 + 1. And you can see that that works. And you can see here that actually this is with this underline squiggle here, or underline squiggle, it's telling me that actually that's a syntax error. And that's coming up as a problem. And it's explaining it here. And that's because we've got the extension installed. So that is done, right? We've got a text editor installed on our machine. We've got VS Code installed. We've got a text editor. We now can start coding in Python. In fact, whilst I've got this directory open, you can see that we're going to start going through these files and talking about each of the topics in detail using VS Code. So that marks the end of this video. Thank you very much for watching. In the next video, we will install Git Bash. And the reason we'll install Git Bash is because this repository is on GitHub and you need to clone it down to get access to it on your machine. So thanks for watching. I'll see you in the next video. Bye-bye. So Git is a version control system, and with Git installed on your machine, you can manage version control using places such as GitHub, GitLabs, and Bitbucket. Okay, so it's important you've got Git on your machine. I have already got 2.35.1 on my machine, which is the latest and greatest version at the point of recording. So I won't be following along with this video because it gets a bit clunky and it switches my video off and it's just not pretty when you're trying to watch and follow along. So I'll show you the steps, get Git installed on your machine and come back to the video. Okay, so click the link here. Oh, sorry, right. We are on git-scm.com. Okay, that's where you'll find Git. And you need to click on the version of Git for your machine type. Mine is Windows. So click on download for Windows. When you get redirected, click on the link that is the right one for your machine. Mine's a 64-bit Windows, so I need the installer for that. I would click this here and that will download the installer. When downloaded, open up the installer and follow along with the easy step-by-step guide, and that will get Git on your machine. Okay, so now that you've got Git, let's open up VS Code in the correct directory, or in your directory that you want this to be. I want mine to be in my course directory. Click here. This is an easy way of opening an instance of VS Code without opening and then scrolling and trying to navigate. Type CMD. When your command prompt opens, just put code space period, and that will open an instance of VS Code in your development directory. So now we need to clone down. So open a terminal. From the drop down, open up Git Bash. Now you'll only have this option if you've got Git on your machine. So that's why it's important you've got Git. Okay. So now we want to use the command git clone. And then after that, we need to dump in there the URL of the repository. So in GitHub, the repository that you want to look for is github.com/bobby-digcoding/Python course for beginners. This is a public repository and all of the documentation is in there. Okay, so we've got all of these different Python files. So if you click code in the main branch and copy this code here, open up VS Code, dump it in there, space, full stop, and that will clone down the repository into your directory. It's asking me for a passcode because I've got an SSH key. There we have it. Okay, so you probably won't get asked for a passphrase. No bother. So this is the supporting documentation. So let's open up one of the first ones. We'll be looking at numbers. So numbers.py, this is the first thing we'll be looking at. These are the supporting documentation. Use these as cheat sheets. So at the end of this course, you can always refer back to these files, make your own notes. It's really, really helpful. I do use cheat sheets still. There's some certain things that I might not necessarily use on a daily or weekly basis, so I just need a refresher. So that would be my advice. Save these on your machine and keep referring back to them. So that is the end of this video. Hopefully now we'll be ready to start really jumping into this course and start looking at Python code itself, and we'll be starting with numbers. So thanks for watching. I've enjoyed making this video. I'll see you in the next video. Thank you. Bye-bye. So I've got VS Code open up on my screen here in the file called numbers.py. There are a few of these files in the supporting documentation that we cloned down from GitHub in the last video, but we're looking at numbers. So we'll close the Explorer because I want to use as much real estate as possible. You can see here I've got a terminal with the interpreter up and running. Okay, that's what these greater than symbols mean. You do that simply by, if we put exit, I'm ahead of myself there a little bit, in the terminal or command prompt, just put py if you're on Windows, and there you go, there's the interpreter. But we'll be using the interpreter to take an input and return an output. So the input will be a sum, the output will be the result. That's what we're doing. We're using it as a calculator. In Python, we have a whole bunch of operators that we can tap into. Let's make that a bit bigger. We've got the symbols, that's the operator, and what it does, the description here. Okay, so we've got plus is addition, we've got subtraction, multiplication, nice and easy, right? Basic stuff. Division, now that will always return a float, which is a number type. We'll talk about that in a second. So 10 divided by 4 would be 2.5. Floor division is the same, but returns the integer version. So 10 divided by 4 would be 2. So 2.5, remove the decimal and a 5 is 2. So that's floor division. Modulus is the remainder of 10 divided by 4, which would be 2. So that's the remainder. So 4 goes into 10 twice. The remainder is 2. So 4 plus 4 is 8. The remainder is 2. That's modulus. Then you've got power of. So star star is, if you put a 5 star star 2 would be 5 to the power of 2. So 5 times 5. 5 star star 3 would be 5 times 5 times 5, which would be 125. That's power of. You've then got assignment operators. We've got equals. Okay, there are other ones. We've got equals equals, got equals greater than, so on and so forth. Now, if you go to Python's doc page, if you look up here, we've got docs.python.org/3/tutorial/introduction.html. That is Python's documentation to an introduction to numbers. I've extrapolated everything that I feel is basic stuff. You can do a deeper dive on their docs. Please feel free. This course has been designed around their documentation. So I wanted to give you the very, very basics, okay? Okay, so we've got number types. We've got integers, we've got floats. Integers are whole numbers. Floats are numbers with decimal places, okay? You've then got fractions, but again, this is a beginner's class, okay? So we'll look at ints and floats today. You've got some built-in functions. We're using round today. So if we were to use round function on this number here, you could pass through a number and then pass through the amount of decimal places you want, and it would return the rounded version. So for instance, if I pass 5.6667 through to this function here as the number, change decimals to 2, that would return 5.67. Okay, we're using divmod. We're also going to use, what else? Power. So these are a couple of other functions that we've got here that are built into numbers. Really, really helpful. Divmod returns a tuple of the result of the floor division and modulus. So divmod 10.4 would return 2.2. We'll look at that in a second. Lastly, before we jump into actually throwing in inputs and getting outputs, Python is a really handy way of representing large integers. So 4 billion, which looks a bit hard to read, can be represented as this: 4 underscore 3 zeros, underscore 3 zeros, underscore 3 zeros. I think it's a really handy way of representing large numbers, especially if you're coding. So, okay, let's look at some of these basics here, and we will dump them straight into the interpreter. So anything that comes after a hash is a comment, and the interpreter knows to ignore it. Okay, the comment is for you. Excuse me. So 2 plus 2, simple addition, is 4. 5 minus 2 is 3. 7 times 10 is 70. Simple stuff, right? All we're using is the interpreter as a calculator. Then you've got division. So 10 over 4 would be 2.5, okay, which is a float, 2.5. Floor mod is the same calculation, but rather than 2.5, it would be 2, because it would disregard the decimal place and 5. 10 modulus 4 would be 2, okay, and then div mod would be 2 and 2, because it's this sum and this sum with 10 and 4. Let's show you what I mean. Go in here, right click, press enter. If I now... It's a bit hard when you zoom so far in when you're doing a screen share to show what we're doing here. Right, so 10 over 4 is 2.5. 10 divided by 4, 2.5. 10 floor division over 4. So 10 with floor division of 4 would be 2, because rather than 2.5, you're removing the 0.5, that leaves 2. 10 modulus 4 is 4 goes into 10 twice, whole, okay? That gives you 8, and the remainder of that sum is 2. That's why it's 2. And divmod, which is a built-in function, is doing floor division and then modulus. So 10, we're passing through 10, 4, and it's essentially doing 2 calculations, 2 and 2. Brilliant. Again, you can spend as much time as you like adding these into your own interpreter. You can always add other sums to give you a much better rounded knowledge of numbers in your own time, but this is kind of a simple walkthrough for you as a beginner. Okay, I'll now copy this. These are fancy sums, so think of BODMAS when you're looking at these sums. So brackets, other, division, multiplication, addition, subtraction, in that order. And what will happen is, let's copy this. Copy, there we go. So it will do this part first because that is the multiplication. So 5 times 6 is 30, 50 minus 30 is 20. It will do this first because of the brackets, and it will do this inside the brackets first because it's multiplication. So it's 50 minus 30 is 20. 20 divided by 4 is 5, which is division, so it will return a float. Then you've got 5 times 3 plus 2, so 15 plus 2 is 17. Okay, I say fancy sums. Sums can get a lot more fancy than that. Then you got 5 power of 2, which would be 25. And I did say earlier, 5 power of 3 would be 125, which is correct. So 2 to the power of 7 is 128, if I remember rightly. No, it's more than that. Oh, it is 128. But you can also use a built-in function called pow, which saves the use of the star. I don't know what's easier to read, but 2 to the power of 7 returns the same, it's 128. Then variables. So it's not really numbers, but you can assign anything to a variable. And today we're assigning numbers to one. So 60 is assigned to the variable width. We're using the assignment operator. Height equals 21, 3 times 7. So width multiplied by height, I think is 1280. 1260. There you go. I was tinkering with this earlier. So rather than doing 60 times by 3 times 7, which is essentially the sum, you're assigning the numbers to a variable and you're using the variables to do the sum itself. Okay? Which is all fun. And lastly, before I close off this video, let's look at this. So in interactive mode in the interpreter, the last printed expression, which is really handy, gets saved to automatically saved to a variable underscore. So you don't need to assign it at all. It knows to assign it to an underscore variable. So if we pop this into the interpreter. Okay. Price times tax has now automatically been assigned to underscore. Okay. So if I now do price plus underscore. Let's just type it in there. That'll be easy. There you go. So price plus underscore is 113.0625. Now that expression has been saved to the variable underscore. So you see how that's gone? Underscore isn't consistent. Every expression, or the last one, is assigned to it, okay? Now if I use round, it's not liking that. So I type it round underscore, comma 2. Remember that function we looked at earlier? There we go. Round underscore. So underscore is 113.0625. Decimal place is 2. So it's 113.06. Okay. So this is my whistle-stop tour of numbers. Okay. There's a lot more to learn. There's fractions. There's all of the different operators. You can do really, really fancy sums using numbers. Please look at the documentation on Python. There's no better place to learn numbers than Python numbers page. This, like I say, this is just all for beginners. So keep the support and documentation, add more notes as you find something else that is interesting. But that is the end of this video. Thanks for watching. I've enjoyed making it, and I'll see you in the next video, which will all be about strings. Bye-bye. So So again, I've got a VS Code instance open on my screen here in settings.py, which is one of the files we downloaded or cloned from GitHub. We look in the Explorer here, you can see there's a whole bunch of other files, but we're looking at strings today. So Python can be used to manipulate strings, which can be expressed in a few different ways. They can be enclosed in single quotes or double quotes. So it doesn't matter, it is still a string if expressed in one or the other way. Now, a backslash is used to escape out of a string, or a quote, should I say. And that's really helpful in one of the examples that I've got in a moment or two. Because there's certain words that use, let's say, an apostrophe. And if you're using single quotes, then you can imagine that you're in a whole spot of bother with that string unless you escape out, okay? So Python strings cannot be changed. They are immutable. So you cannot isolate a character in a string and replace it with something else, okay? You have to create a new string altogether, which is completely possible. We'll be looking at a built-in function called len in this video. Now, len is really helpful. You can use it on strings, lists, dictionaries, tuples, sets, and it returns the number of items or characters in any one of those objects. Really helpful with strings. So if we called len on my name, which is Bobby, it would return 5 because Bobby has got 5 characters in it, okay? Strings have a whole bunch of methods. Now, these are really, really helpful, okay? So I've listed out all of the different methods that you can use on a string. So for instance, capitalize there, you've got a bit of space. So if I put BOBBY as a string, capitalize would return Bobby, okay, as a string. Really helpful method to use. And you've got a whole bunch of other stuff here as well. You've got casefold, sent, account, encode. What else? Other examples. So that you got right at the bottom there, you got upper. So that would just be Bobby would return Bobby is all uppercase. Okay. So really helpful methods when managing strings. You'll be using them a lot. Okay. You now need to open up a terminal and open up a interpreter. So I'm in Windows, so PY. I've got my 3 greater than symbols there, so it's ready for an input. So I've got a few examples here that if I pop them straight into the interpreter, we can see what's actually going on here. Okay, so the top here, we've got spam and eggs in single quotes as an input. So the output is a string, spam eggs. Doesn't has an apostrophe. Okay, so we've got single quotes and single quotes. Because we need to use a single quote in the string, you need to escape out using backslash, and it converts the single quotes to double quotes, and then you return your output is doesn't with double quotes. Really helpful understanding the backslash. Or you could just write that string as double quotes and you won't have any problem whatsoever. Now in this example, we've got double quotes in the string itself that haven't been escaped out. So of course, what gets returned is that whole string. The double quotes within the string are characters. The way that you can escape out and use the double quotes in the string itself, would be to use the escape and it changes the double quotes to single quotes. That is pretty much the polar opposite of the doesn't example. So with doesn't, we had single quotes and we used an apostrophe. In that example, we're using double quotes, and actually we want to use double quotes in the string, and in which case you need the escape backslash. Okay? If you look at the documentation on Python, if you look in 3.1.2 on docs.python.org/3/tutorial/introduction, that is their intro to strings. So do a deeper dive in there. I've extrapolated out a whole bunch of stuff. Hopefully that is just the basics that I've got in my video here. Okay, so next we've got new line. So new line is represented in Python with \n. Okay, and if we were just use the interpreter, it comes out as a single string. It just ignores the new line. But if you print it from a variable, it will pick up that new line and print it as first line, second line in this example. So if I use this, copy, bump it in there. So we're saving first line, new line, second line into an S variable. If we just return S, it just prints out the return statement. It doesn't do anything. But if we use the print statement and pass through S, then it picks up that new line, first line and second line. That's really, really helpful when you're trying to format certain strings to a user, maybe in an API message, something like that. Right. Next, we've got raw strings. So we can use R for regular expression to print out raw strings, because you can imagine a path here will have backslashes, and this example is a great one because it's got a /n. So if we were to print that, it's just going to come out something silly, because we know /n is new line in a print statement. But if we use R as a regular expression, you can see, like, you can see C sum name has been done C/sum, and then it's printed out this. But if we use regex, then it's absolutely fine. Okay, string literals. So you can use 3 quotes, whether it be single or doubles, and that will print out everything under that. So it's sort of like a comment. So a comment is a hash, but it's a single line. A string literal can span numerous lines. And I've done that at the top of the page here for my description. Okay, so that's what a string literal is. Copy that, dump it in here, and it will print it out exactly as you want it to be. Okay, then you got concatenated, basically glued together. So if we use the number 3 multiplied by un, that would basically do un, 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 and then the plus symbol, the operator in this case, is concatenate, and that will glue un, un, un with ium. So that should bring that in there. There you go. You don't even need to use the operator plus. If it's 2 strings put together like that, Python knows what you're trying to do, and it would actually join it together. The coding, really helpful stuff. But that's really helpful when your strings in a text or parentheses there span more than one line. Python knows what you're doing, and it would just join those together. Okay. So this only works with 2 literals though, not with variables or expressions. So we're going to have an error here. We try and dump this in here. Okay, so it's basically because we've got a variable and a string, whereas what you need is 2 strings. So prefix equals did, and then you got prefix with that. What you then need to use is the operator, and then it will work just nicely. Okay, so the removing the operator will only work when you're using 2 strings. That's what I'm trying to put there. In indexing, so strings, sorry, I keep hitting my mouse button, it's really annoying. Indexing, so we need to understand indexing for things like strings and lists. Okay, and I love this. I took it straight from the Python website. But an index, it allows us to play with certain characters in a string based on where that character is in the string by its index. So the first point in a string is 0, and the last point is, in this case, A or -1. So you can reference the string from the front, so 0, 1, 2, or you can reference it from the back, -1, -2, -3. So when we're working with a word such as did coding, if we go word square bracket 0, we're referencing the first index of the word did coding, which would be D. Okay, let's dump all of these in my interpreter and see what it spits out. Okay. So right, so the word is did coding. So word index 0, that's the first, as per this diagram at the top here. 0, 1, 2. Okay. Word 5 would be, well, it's printing out little d. So it's 0, 1, 2, 3, 4, 5. So it's D. Okay. So you can see that that's working. You can reference, so if you put 0, 2, that will be include and exclude. So it's include 0, 1, and exclude 2, which is DI. Include 2, 3, 4, but exclude 5. That's what that means. Okay. So it'd be DCO. If you miss the first integer in this expression, it assumes you mean 0. So that would be 0, 1, exclude 2, which is DI. If you ignore the last integer, it assumes you mean the very last, or let's say -1. Okay. So that will be everything from 4 to the end. And then we've got some other examples there. Okay. So we've got so we're referencing -2 to the end, which would be NG. There we go, NG. And then you can bring these two together, so you can join them together. So it's everything up until, but excluding 2, and everything from 2, everything to the end. You join them to, it brings together decoding. And then again, you've got another one here, which is an example of bringing that together. Okay. So that's indexing. It's really, really, really helpful. So changing strings. So if we wanted to change, so referencing the D, but assigning P, it says, no. Type error. String object does not support item assignment. It's immutable. So if what we do is have the string P plus word, which will be included in the first, so this will be everything from O onwards, that will work, and it will change it to PID coding. Or equally, we can do this. DIDI, okay? So we are just manipulating strings. That's what we're trying to do and demonstrate in this video. Okay, we're using len. So if we look at Bobby Decoding, which is the GitHub username, it's got 15 characters in that using the len function. Really, really helpful function. You'll be using that quite a lot. Handy built-in functions. So when you don't need fancy outputs, but just want a quick display of some variables for debugging purposes, you can convert any value to a string with the repr or the str functions. So here's a list of just some handy little functions that you can use, okay? And here are some examples of what you can do. So xy, y400, what you can do is dump them in here, and that will just give you a really handy representation of what you're trying to achieve. Same with str, it will just change everything to a string, okay? And then you've got there we go. So let's give those examples there. So we've got format, okay? So there's a bit of an explanation here. In Python 3, you can use the F string, which is F followed by two quotes, and then you can use placeholders to add variables, but you can also use format, which is valid for Python 2 and 3. And what we're doing here is we're doing a print statement and we're adding placeholders. That's what these squiggly brackets are. So it's placeholder and placeholder, and then dot format, which is the method, and it goes in order. So spam will be injected into this placeholder and eggs will be in that placeholder. And equally in this second example here, we're just changing them around. So nor is the first item and 1 is the second item in this tuple. And that will just change it around, eggs and spam, okay? So that's my whistle-stop tour of strings. There is more to go in and do a deeper dive on Python's website here, but do that in your own time, do a bit of bedtime reading, okay? But that is the end of this video. I'm glad that I put it together. I hope you've enjoyed it, and I'll be seeing you in the next video. Thank you, bye-bye. Okay, like always, I've got Visual Studio Code open on my screen in the list.py file. So this is just one of the pages in my supporting documentation that we cloned down from GitHub a couple of videos ago. We don't need the Explorer open. We want as much real estate on a screen here as possible. So we'll be manipulating lists today. A list is a data type. So there's 4 different data types that Python knows of: lists, dictionaries, sets, and tuples. I'm going to do a video on each, so I don't need to explain the difference in them, except for lists are written as a list of comma separated values or items between square brackets. Okay, so a list will look like this. Okay, that would be considered a list in Python. Okay, now lists are mutable. So unlike strings that are immutable and tuples that are immutable, a list is mutable. You can change and alter the items in lists. So you can identify a certain item and you can replace it with something else. Okay, so they're mutable, which is really, really helpful. I have also added on all of these pages, if there's any methods that are associated to a particular, let's say data type, or let's say numbers or strings or anything, I've listed those methods in the files themselves. So lists have got methods such as append, which allows you to add an element to the end of the list. You've got count, extend, index, reverse, sort, so on and so forth. When you have a bit more time outside of this video, just have a tinkle with lists and just play with these methods. They're really, 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 really helpful. Okay, so into the basics. We will need a terminal open and we will need a Python interpreter in interactive mode. Okay, we've done that 100 times in this course already, so all you need to do is fire it up. 3 greater than symbols shows me that it's ready for an input. So this is a basic list, and we're assigning that to a variable called squares. Okay, so dump that in here, and now we can access squares by just doing that, and it will just print out in the interpreter the list. Okay, so that is a list in Python. Okay, we've then got, scroll down, indices. So this is exactly the same as we went through in the string. I haven't changed this to a list, but essentially imagine that this is a list. You can change these to square brackets if you like. But essentially, each item in a list you can reference by its index. So in this case, this is 0, this is 1, this is 2, this is 3, and this is 4. In the same way as in this string, you've got 0, 1, 2, 3, and 4. You can reference it from left to right, 0, 1, 2, 3, and 4, or you can reference it right to left, which would be -1, 2, 3, 4, 5. Okay, same as string, but understanding indexing is paramount in Python. It's really, really helpful. So if we put squares 0, it will return 1. Squares -1 would return 25. -3, so slicing, when you use a colon, that syntax means include everything from -3. Having the missing integer means to the end. It assumes you mean to the end. So -3 would be 0, 1, 2, 3. So it would return all of that. Okay, so if we copy all of this, and we bump that in here, there you go. There we have it. Right, okay. So creating a list copy, this is quite handy sometimes. Just open bracket, close bracket with a colon in the middle. Now do an outright copy of the list. You can assign that to a variable, and then you can change that copy as much as you like. It doesn't affect the original. It's a handy way of creating a copy. Concatenation. So same as strings, you can glue things together. You can glue strings together. You can glue lists together. Okay, so if we take the variable squares, we can glue a second list to it. And then what you've got is a much bigger list. Oh, sorry. So, right, okay, let's go squares _2 equals, and then we'll dump that in there. If we then put squares _2, there you go. Oh, my typing's fantastic. So squares remains the same because we didn't assign it to a variable. Then I did assign it to a variable called squares2, and this then becomes this. Okay, so that's concatenation. That is essentially gluing two lists together, which again is really, really helpful. Right, you can alter items. So unlike strings where you can index the character, but you can't change it, in a list you can. So I can find 1 by its index and I can then replace it. So in cubes, you can see we've got 1, 8, 27, 65. That's incorrect. Okay, that should be 64. So 4 to the power of 3 equals 64. So we need to reference this by index, which in this case is index 3. So it's 0, 1, 2, 3, or you can go -2. So that could just be -2. It's the same way. You're just referencing it from a different direction. And you can then put equals 64. So you're referencing the item in the list and replacing it with the new number. And then we'll print cubes again. Okay, so now the new list is 1, 8, 27, 64, 1, 2, 5. So it's mutable. You can change the items by indexing them and then assigning them with the operator equals. And that's the same way as we do it in dictionaries actually. You reference the key using this method with the key name, and then we use equals to assign a value. Okay, so it's the same as in dictionaries. List method, so we've got append. So with cubes, we can now append 216. Let's just do that. We'll use append to do an operator of 7 to the power of 3. And then if we put cubes, you can see that the list has just grown by 2 because we've appended 216 and then 343. Okay, so we're using the method append. Adds an element to the end of the list. This is your cheat sheet. You'll be referencing this page a lot in the near future. So keep adding to it. If you find other methods that are really helpful, just keep adding to this cheat sheet and save it, and you've got it as reference point in the future. So length, we looked at this in strings. It just returns the amount of characters, or in this case, items in a list. So that should return 4 because we've got 1, 2, 3, and 4. Okay. 4. Really, really helpful. Then you've got nesting. So nesting, we've got one list, A, B, C, and D. We've got another one, 1, 2, and 3. If we assign both of them within another list to a variable X, X is a list that contains lists. Show you what I mean. Okay, so you got square brackets that contain one list and a second list. Hopefully that makes sense. So to get this list from its parent list, you reference X with index 0, because this is index 0, this is index 1. So X 0 would return the first list. So then if we want to get B from this list, it would be X 0 and then index 1. So we're grabbing that list. From that list, we're then grabbing B by that integer, and that's what we're doing here. So spend some time understanding that. It's really, really useful with lists, but especially with dictionaries as well, because you might be working with dictionaries or JSON, and in which case you're referencing keyword after keyword after keyword just to access different values, especially with API calls and things like that. So it's really, really helpful to understand that. List comprehension. Now this is a little bit more advanced than what I would normally put in one of these kind of courses, but because we're using a control flow, so we're using a for loop. So list comprehension allows us to write this piece of code here in one line, essentially. So I'll just gloss over it quickly. So don't worry about this. We'll go through control flows in another video. But using this piece of code, we're creating a list. I won't go through the ins and outs of what we're actually doing and how we're looping through, but we're creating this list here, okay? By using this one line of code, which is called list comprehension, you don't need to use multiple lines of code to create that same list. You can just go with one line, and lo and behold, it creates exactly the same list, but with a much easier syntax, okay? We'll go through loops a little bit later, but list comprehension is massively powerful, so please read up on it. If you go to Python docs on this page, which is docs.python.org/3/tutorial/introduction, it gives you a rundown of numbers, strings, and lists. If you scroll down to the bottom, near enough to the bottom here, we've got, where are we? There we go, 3.1.3 lists. So it goes into great detail there, and if you do a deeper dive into Python docs, you've got a lot more to read about list comprehension, okay? So go back in Visual Studio Code. We've then got the final bit of this video, which is built-in function, which is called list. So this function will convert, in this case, it's a tuple, into a list. So it just takes one object and it converts it, or tries to convert it into a list if it can. So this is just a tuple, and a tuple is defined similar to a list, but instead of square brackets, it uses just standard parentheses. This function is converting that into a list. So it will change that to square brackets. Okay, so there we go. Bobby@deercoding.com. Okay, so that's my whistle-stop tour of lists. Like I said, this is geared towards beginners. You've got supporting documentation. This is your cheat sheet that you've got on your screen here. Read up on lists, play with lists, and add to this cheat sheet as and when you find something interesting. You can keep referring back to this as long as you want. 2, 3, 4, 5 years down the line in your career, and you may find something useful. Okay, so that marks the end of this video. Thanks for watching. I've enjoyed putting it together. I'll see you in the next video. Bye-bye. Okay, so we're looking at tuples today. This is my Visual Studio Code instance opened up in the tuples.py file that is contained within the supporting documentation that you can clone down from GitHub. Okay, there's loads of files in here. The structure of this course is that I will just walk you through and talk a little bit about tuples from this form, because this is kind of a cheat sheet, if you like, for you to use. And we'll give you a rundown of what a tuple is, and then we'll give you some examples of code so we can actually start understanding how to work with tuples. So Python knows of 4 compound data types: lists, tuples, sets, and dictionaries. Okay, on the documentation it talks about lists, their tutorial for beginners documentation, but they don't really talk too much about sets, dictionaries, and tuples. So I thought I'd put 3 videos together to help you out, and also put the documentation together so you can reference it. Okay, so tuples are written as a list of comma separated items surrounded by parentheses or brackets, unlike list, which is square brackets. Okay, now tuples are immutable, which sets it very much aside from lists that are mutable. Okay, so you can't assign items to a tuple where you can in a list. Okay, so that's an important difference between the two. Tuples have two methods available. They've got the count method and an index method. So you have a tuple.count will return the number of elements with a specified value, and tuple.index parentheses returns an index of the first element with a specified value. Okay, they're the two methods that we have on tuples. Okay, so let's jump straight into a few code examples. Open up a terminal and fire up an interpreter. And the first line here is an example of what's called tuple packing. We will also talk about unpacking of a tuple in a few moments' time. So what we're saying here is t, which is a variable, with an assignment operator of equals. Then we've got three items. So we've got an integer, and a string. We're saying here that we want to assign or pack these items to a tuple named t, because that's the equivalent. This expression is the equivalent of doing this. Okay, but you don't need those parentheses to do it because it's a tuple. So we can then access the first item by its index of 0. If you don't know much about indexing, I'll talk about that in a few moments' time, and then we'll just print it out in the terminal, in the interpreter. Okay, so T, 3 items, referencing the first index, which is this one here. If we then put T, 1 would get the second item in the tuple. But you can see here, just by printing T, do it again. That shows you that you don't need to put the parentheses to pack a tuple. Okay. Tuples can be nested. Okay, so here we've got U, so we're assigning T, which is a tuple. We've got a trailing comma, and then we've got another tuple here. We're essentially using the packing of a tuple to create one tuple with nested tuples. That's really what we're doing here. So if we put U equals T trailing comma tuple, and then put U, you can see we've got the open parentheses here is the first tuple, and then we've got one item. We've got another item. Okay? You can't assign to a tuple. It will come up an error. Type error. Tuple object does not support item assignment. Okay, that's a demonstration of a tuple that is immutable. You cannot assign values to items in a tuple, where you can in a list and a dictionary and a set. So they can contain mutable objects, however. So let's create another variable called v. And here, if we put v, you've got a tuple with 2 lists in it. So we can now go v first. So this will be the first list. And then we can say first index, that would be 1 equals 2. Okay, if we now put v, 2, 2, 3. So although the tuple itself is immutable, the lists that are mutable, that are within the tuple, can be altered. You can assign values to items in the lists. Okay, so that's the example I've got there. You can see that we looked at the first or 0 index, which is this here, it's the 1. So this becomes the 0 index of the tuple, and that is the 0 index of the list. And we're equals, using the assignment operator, 2. So that's why this becomes 2, 2, 3, 3, 2, 1. Okay? Indexing. I've talked about this in previous videos, but I love this. It's really, really helpful. It just shows you that if you're referencing a string or a list or a tuple from left to right, then the first item in the list or the tuple or the string or so on and so forth is 0. Second one is 1, 2, 3, all the way up. So that's going from left to right. If you reference it from right to left, then it's -1, -2, -3, -4. So you have options of actually identifying certain characters or items in objects by their index. Really, really helpful. So we can get the 0 index of T, which we know is 1, 2, 3, 4, 5. We can get the last index of T with -1. But we know there's only 3 items in that tuple, so we can also reference the last item with 2, because 2 is also the same index in this instance as -1. Hope that makes sense. Trailing comma. Okay, let's get this example in here. So we're creating a variable with an empty tuple called empty. And then we're creating, I had a test in the last time I did this. Let's do that again. Do apologize. Okay, so an empty variable, empty becomes a variable that contains a tuple, which is empty itself. Singleton has just one string with a trailing comma. That's how singleton is going to be created as a tuple. That's how we know we do it. You only need a trailing comma when a tuple contains one item. So we then use the len function to calculate the length of empty, and we know that there's nothing in there, so we'd expect it to be 0. Singleton has 1. So if we print singleton, it says hello with a trailing comma. Okay, there we have it. And we've then got unpacking of a tuple. So at the start we said t equals, and we had an integer, and a string. We can do the opposite of that and create 3 variables. I do apologize. Create 3 variables and equals t. And what that does, it does the complete opposite. So it takes each item from a tuple and it assigns it to its corresponding variable in order. So x becomes index 0, 1, and 2. So we'd expect that to be 1, 2, 3, 4, 5, so on and so forth. So let's go ahead and do that. Copy. We don't need that in there. Okay, so it's unpacked it. So x becomes 1, 2, 3, 4, 5. We've got 5, 4, 3, 2, 1 to y, and then z becomes hello. That is called unpacking a tuple, which is really, really helpful when you're working with tuples. And you see that in quite a lot in code examples. Then you've got built-in functions. So we've got tuple as a function. So tuple, open parentheses, and basically in this example here, I've just got a list that contains a whole bunch of string. And when you add the function tuple to it, it converts that list into a tuple. Okay, so although it starts off as a list, by using the tuple function, it converts that list into a tuple, and now that is immutable. Okay, we can't assign anything to at. So if we went x 1 equals bat, it would say you can't do it. Whereas beforehand, I would have been able to because it was a list. Okay, then you've got tuple comprehension, which is very similar to list comprehension, except you're using the tuple function to convert that into a tuple. That's, it's just an example of how you can use the tuple function. Okay, so that is it. So if I stick that in here, look, it's just an example. Okay, so just use normal list comprehension and can use the tuple function to convert it into a tuple. So I won't go into great detail about what that's doing because we're using an example of a control flow, which is a for loop, and you use list comprehension to change what could be 5 lines of code into 1 easy to read line of code. That's list comprehension for you in a nutshell. But we'll look at that a little bit later. It's kind of an advanced or intermediate kind of topic. So let's not worry about that. So that is tuples. Thank you very much for watching this video, and I'll see you in the next video where we'll start looking at sets. Okay, thank you, bye-bye. Okay, so we're looking at sets today. You can see here I've got a VS Code instance open in a file called sets.py. If you don't know where this is or how to get hold of it, then a few videos ago, we cloned down a supporting documentation repository for this course. So get your hands on that and you can follow along. But the structure of this course and these videos is that I'm showing you and explaining what certain things are, and then we've got some code examples to walk you through. Nice and easy. So let's talk about sets. So Python knows of 4 compound data types, which I keep repeating because I say that at the start of all of these videos, and it's lists, dictionaries, tuples, and sets. Today we're talking about sets. If you look at their documentation, they don't really talk too much about sets in their beginners tutorial, so I thought I'd do a video just to walk you through it and help you out. So sets, they are an unordered collection with no duplicate elements. Like a dictionary, a set is defined with curly brackets. So sets are really handy. They're kind of like lists, except a set cannot have duplication. Okay, so a list, you can have duplicate item after duplicate item all day long, not a problem. Whereas a set, it cannot. It has to have unique items. So that's what's kind of where it stands apart from lists. Now, I could talk about this in a future video perhaps, but when you use the set function combined with lists, it's really, really helpful to look at all unique items within a list and do a comparison and do some analytics. Really helpful stuff. So I use sets all the time. Anyway, so a set is mutable. It's like a list. A set is mutable. You can assign values to items in a list. You can't in a tuple. Okay, so that's important to understand. And also, sets come with a whole bunch of handy methods. Okay, so we've got add to add an element to a set. You've got clear, removes all elements from a set, so on and so forth. I'll let you read through those methods in your own time. But like with a lot of objects and bits and pieces in Python, read up on the methods because they can save you a hell of a lot of time. Because if you don't know of the methods, you will try to code that in yourself and you might use 10 or 20 lines of code to do what essentially one little snippet of code can do for you in seconds. Okay, so read up on those are really, really helpful. So code, let's open up a terminal and fire up a Python interpreter. There we have it. So all we'll be doing is copying the code and dropping it in here. Okay, I'm hoping it's big enough for you to read. Okay, so here we go. Basket equals, and then we've got curly brackets, curly brackets. Now, when you're just glancing at code, it's easy to get confused with a set and a dictionary, because a dictionary is also curly brackets. But what is different in a set is that it's just comma separated, whereas a dictionary has key value pairs, which are comma separated. Okay, so looking at this, I know that this is a set, but you can see here we've got apple and apple, which is duplication. Okay, so if we were to then print basket, what it does, it prints the variable without the duplication. Okay, does that make sense? So although we're assigning this set to the variable, Python in the background is taking that set and it's removing the duplication. Okay, but there is some funky little ordering that they do, which you then have to sort, but we won't come on to that in this tutorial. But when you're tinkering with compound data types, you will find some weird and wacky stuff that goes on, so you'll have to get quite creative. So we've then got orange in basket, so fast membership testing. Okay, so we're saying, does basket as a variable contain the string orange? Okay, which we know it does because we printed it out here, so we've got orange. So we're saying orange in basket. Fast membership testing. Really, really helpful. Crabgrass says false. So it's just a Boolean, true, false. But really helpful to understand. Okay, and then you can demonstrate set operations on unique letters from two words. Okay, so we're using set as a built-in function. So we've got a set. Then we've got b set. So we've got two variables. So if I put a, and I put b, okay, you can see here that D, B, C are A. So it's removed the duplication of B, it's removed the duplication of A, and so on and so forth. So you can say A minus B. Okay, so we're now comparing sets against one another, and we're using these operators here. So these are all of the different operators that we can use to compare. These are called set operations. Okay, so we've got the bar. So letters in or B or both, really helpful when comparing data in these compound data types. Letters in both A and B, so we're using the ampersand symbol there, and then we're using this operator to say letters in A or B but not both. Okay, that's what that operator means. Okay, so there's always, do your research on sets. When you're looking at sets and lists and comparing the two and doing some sort functions on them, it's really helpful to understand what we're doing here, because you can actually get a lot of output with very little input by using these methods and operators. Okay, so in your own time, have a good read up. But this is your cheat sheet. So if you find something interesting on Python or in a YouTube video, then add it in your cheat sheet. You can always reference back. I do all the time, by the way. Then you've got set comprehension. So in the last video, I just did list comprehension and used the tuple function, but you can actually use squirrely brackets here just to go straight into set comprehension. There we go. We go A. There we go. So we're saying X for X. So this is control flow. So like I've said in the previous two videos, so using comprehension allows us to create a set or a list or a tuple by doing a loop of a variable or another list or so on and so forth, a dictionary. But you can do it in one single line of code, and it's much easier to read than, let's say, 4 or 5 lines in a for loop. Okay, there's an example in my list video. And then you've got built-in functions. So we've got set, which we talked about a moment ago. So we've got Bobby at decoding.com, creates a set object. There we go. So again, the ordering is all squiff. You go Bobby at decoding.com. I'm sure there's some logic as to why it comes out like this, but we've got com at decoding.bobby. But essentially, it's done the work. So it's gone through that, in this case, tuple. It's converted it to a set and removed the duplication. So it's in the background of Python, it's doing that work for you. Like I say, when you're coding hundreds and hundreds of lines of code, it's so good that we can use these functions to really minimize what we're doing and get the same output. Low amount of input, same amount of output. That is the key. And that marks the end of this video. So thank you very much for watching. I've enjoyed putting it together. Join me in the next video where we'll start looking at dictionaries. Thank you. Bye-bye. Okay, so we're looking at dictionaries today. You can see I've got VS Code open up on my screen, and it's in the dictionaries.py file in the supporting docs for this course. Please, please, please clone down from my GitHub repository. If you do that, which we've gone through in all of the previous videos, you will have a directory that looks like this. It's essentially a directory tree of Python files that can be your cheat sheet. So when you're learning Python, always reference back to these. Really, really helpful. Okay, so we're in dictionaries.py. Structure of these videos is that I'm going to just talk about what dictionaries are, give you some code examples. We'll fire up an interpreter and we just put some code in and have a little play. Okay, so like I've said in the last 3 videos, Python knows of 4 different compound data types. Now we've got lists, tuples, sets, and dictionaries. I love dictionaries. They're like a powerhouse. You can store data really, really easily. They're very similar in a lot of ways to JSON. So you reference values by keys, and they're just really, really helpful. You'll be using them a lot. So dictionaries are great for storing data values, and it's in a key value pair. So I've got an example of a dictionary here, but we won't put it in the interpreter because we'll be doing that in a second or two. But essentially, like a set, a dictionary is referenced by curly brackets, but unlike a set, we have key value pairs separated by colon. So we've got a key, which is a string in this instance, and we've got a value, so it's a string, so it's a key value. Then it's separated by a comma. So dictionaries are great in text editors when they're expressed in this way. So each key separated by a space and with some white space here, and then you can have your value. It's much easier to read. So we've got the second item here, which got a key, and then you've got a key. This is a string. Third one, we're actually using a list as the value. And then the last one, we've got a dictionary as a value. Okay, so you don't just have to have strings. You can have lists, sets, dictionaries. You can use integers, strings, whatever you like as the value itself. Okay, dictionaries are mutable. This means that item values can be changed, which is important. Okay, we've then got this, which I've enjoyed putting these together, right? So lists, sets, tuples, and dictionaries all have a bunch of methods we can tap into. Now, when you're coding, these methods are really, really helpful. If you don't know of them, or if you've never heard of these methods, then you might find yourself doing line after line after line of code just to do the same thing as this little snippet can do. Essentially, it would be dictionary dot, and then you could have clear, open bracket, close bracket, and that will remove all elements from a dictionary, okay? All of these methods, tinker with them in your own time. Open up a text editor, have a play, run some code, and you will become fluent in these very, very soon. But you've got a whole bunch of them that you can tinker with. So do that. I urge you. Okay, so let's open up a terminal and a Python interpreter. Okay, and then we'll dump in some code. So we'll put the dictionary that we were talking about a moment ago in here. Okay, and we've assigned it to sumDict. So if we put sumDict, the interpreter will express a dictionary in this way, which is hard to read. Like I said in the last video about sets, sometimes you can look at this and go, oh, curly brackets, it's a set or it's a dictionary, and get it wrong, because for it to be a dictionary, it's key value items separated by commas. A set is just item, item, item. Okay, but look, you'll get used to it after a while. So this is key value separated by a colon, but each item is separated by a comma. So it's key, colon, value, comma. Key, colon, list is the value, comma. Okay? You'll get used to it. We've then got this. So this will return an error. So if we were to, unlike a list, so if we were to reference an item in a list or a set or a tuple, we could reference the item by its index. So the very first item in a list, set or tuple, you can reference by index 0. If I do that on the dict, it will come up with an error because you don't reference items in that way. Got a key error. Okay, there's no such key as 0. You need to reference key value pairs by a key. Okay, so in this case, we could put some dict, key error, sorry, not key error, a key. So we're referencing a key and the value is a value. And this one we put a key 4, we should get a dictionary back. There we go, because we're then referencing this. Really helpful. But you manage dictionaries in a slightly different way as what you would a list, tuple, or a set. You've then got creating a dict copy. This is one of the methods I was talking about. Really helpful. If you want to create a copy of a dictionary, you can then assign that to a new variable and you can alter it. You can change some of the values, and then you've got just an absolute copy of a previous dictionary, and the previous variable is safe and you haven't got to worry about that. So again, that's quite a helpful method for you. So you've got altering a dict. So we can, like a list, we can use the assignment operator and assign a new value to a key value pair. Okay, so add the cube of 6. That's a hangover. I used a lot of the same code examples across these. But some dicts, so what we're doing now, we're assigning a new value to there, and then we're printing out the value for a key, which is now a new value. Okay, so we're assigning a new value to a key value pair. Use again len, which is the len function, the length function, and that should return, in this case, 4, because we've got 4 items in a dictionary. We can then use the keys method, we'll return all the keys. Okay, then you've got the values method, will return all the values. Okay, so if you want to do some analysis of the keys, of the values or key value pairs, you can do that by using some of these methods. Like I said, spend some time going through them. So what have we got here? Keys returns a list of containing the dictionary's keys. You've got pop, that will remove the element with the specified key. Okay, so you can specify the key, pop, and it will remove it from the dictionary. Okay, so there's all these different fancy things you can do. So spend some time going through that. You've then got dict comprehension, which is the same, very similar to list comprehension that we looked at in the last few videos. So again, I won't spend too much time about control flows because we're covering that in a future video. But list, dictionary, tuple, and set comprehension essentially means that you can create a dictionary using just one line of code. It's much easier to read. Do your research on list comprehension and dict comprehension outside of this tutorial. I've got this example here so you can actually see what it's doing, or at least understand the syntax. But if we do this, there you go, we're creating a dictionary with a key of 2, value 4, key of 4, value 16, and so on and so forth. Okay, so we're basically looping through this tuple and we're creating a key and then a value of, it'll be value to the power of 2. That's why we're getting 4, 16, 36. Okay, so I'm not glossing over comprehension. They're really, really powerful, but this is a beginner's course and I don't want to get bogged down in some of the bits and pieces that you don't necessarily need to know at this point. I'll do a future course that would be an intermediate level and we'll start looking at comprehension and things like that. Tips and tricks. Then we've got built-in function dict. So this is on all of those forms. So you can just, we can check, so the dict function will take keys and values and it will just convert them into a dict. So it creates a dictionary object. So if we use this, there we go. So we've got A equals 1, so it's A1, and you've got B2, yeah? So it's converting that syntax using the dict function and it converts that into a dictionary, which is really helpful, right? It saves you having to use comprehension, saves you having to manually write that in your code base. So I hope I've done dictionaries some justice. Dictionaries are, like I say, it's a powerhouse. We use them all of the time. I certainly do. And when you become a master on dictionaries, they can really, really be helpful when you're writing code. When you start tinkering with modules such as JSON, they're so closely aligned, it's really, really helpful to understand. So that marks the end of this video. I hope you've enjoyed watching it. I've enjoyed putting it together, and I'll see you in the next video where we'll start having a look at control flows. Catch you later. Bye-bye. Okay, so if statements. Really looking forward to this one. I use if statements all of the time. They're fantastic. Okay, I've got VS Code open in ifstatements.py, which forms one file from the wider support and documentation for this course. Download or clone it down from GitHub. Please do that. If you're learning to code, it's always good to have a reference point, and you can always reference back to these files as and when required when you're just scratching your head a little bit. So please, please, please do that. Okay, let's move on. So let me talk about if statements a little bit. I will try not to butcher my explanation of what an if statement is, and then we'll look at a code example, okay? If statements. So the conditional statements, right? Now, you and I, as human beings, we kind of work through this logic naturally in our day-to-day lives, okay? An if statement is just a way of taking that logic and putting it into your program or into your code, okay? So an example of that logic would be walking down a road or down a pathway and you want to cross a road, okay? So you don't just dart out across the road and run across the road. You're gonna get hit by a vehicle, right? It's not gonna be pretty. Instead, you use some logic, okay? You approach the crossing, or you get to a point where you want to cross the road and you stop. You check to see if cars are coming. Are there any cars coming? Yes or no? If yes, you don't cross. If no, then you may cross. Or you might then say, well, is it safe for me to cross? If yes, cross. If no, check again. Loop through that process over and over until you are completely safe that you are ready to cross that road, okay? It's kind of one example of logic that you use in the real world. You want to make a cup of coffee. Do we have milk? Yes, we do. Make the cup of coffee, okay? Logic. And an if statement would take that logic and allow you to use that in your program, into your code, okay? Probably butchered that a little bit, but that's if statements. They're fantastic. So think of an if statement as a way to check to see if conditions are met. If a condition is met, do something. Else, do something different. That's kind of what I was trying to explain. Elif stands for else if. Okay, so you do if, and you'll have else if. Now an else if is optional, and then at the end of the statement you could have else, which is kind of a catch-all. That's optional too. An if statement only needs to consist of the if statement itself. Okay. Both elif and else are optional. Okay, no, it will be defined, or I will be, sorry, I can't read. I will be defining a function in this demo. We'll talk about functions in a later video, but just bear with me, okay? You may or may not know what functions are, but this is using a keyword def. We're calling it number play. That's the function name. And we've got parentheses where we're passing through a parameter or an argument, followed by a colon, and then this essentially, forget the function, that statement that you're seeing on the screen here, that is the if statement. But I'm just putting it into a function so I can make calls against it. So let's have a little look. So all of this here is optional because it's elif, elif, elif. You don't need any of that. You don't need it, it's optional. But if is the start of the if statement, so x. So x is the variable here. So imagine x is 10, an integer. Okay, so we're saying we're using this expression here, which is less than. So if x is less than 0, so it's a negative number, so -1, -2, what we say is x equals 1, oh sorry, 0. It's been a long day. And then we print negative changed to 0. So that will appear in our terminal or in our Python interpreter. Elif, so else if x equals, so this is checking to see if x is equals to something. So we're saying if x equals 0, print 0. If x equals 1, print single. Else, so this is the catch-all, so all other numbers, so that could be 467. So if x equals 472, it will just print more, okay? So that's the catch-all. So by calling this function, if I pass through -1, we would expect to see this. 0, then the third one down here would be single, and the last one would be more. That could be, like I said, that could be whatever number. It would just print out more, okay? So let's get that in our terminal. Let's open up PY, Python interpreter, and let's dump this function. There we go, this may work. I might need a little bit more white space, but let's have a look. You can never be too careful with, there we go. So that's now working, right? So number play is now a function. It looks a little bit messy in the interpreter. When you see these 3 periods there, that basically means that it's expecting another line because a function, very much like an if statement, has a colon at the end. That means that the actual code appears in the next line after some white space, okay, which could be 4 spaces or 1 tab. So the function is in there. Now let's call it. Now we'll call number play, and we'll call it with an argument -1, negative change to 0. Okay, so let's go and we'll change that to 0, printing 0 because this was not met. So is there a car coming down the road? Yes, there is. Is it safe? Cross the road. Okay. I want to make a cup of coffee. If there's milk in the fridge, is there sugar in the cupboard? So on and so forth. Okay, that's kind of what we're doing. Sorry, I'm really butchering if statements here, but look, I'm having fun. So, okay, and then this last one here, there isn't actually a number, I deleted it. So we can put it, it's just saying more, okay? So that is just a single example of if statements. I could do so many examples of if statements. I could make this video last an hour long. I don't need to. This is a beginner's course. I'm just trying to show you what an if statement is, what a control flow is, how your mind should work when you're writing code that contains if statements, why and where to use them. There is actually another video that I'm going to put together about match statements, which are pretty new to Python 3.10, which kind of take if statements to the next level. They're kind of like a switch statement in other languages. But if statements are kind of entry level. So one example, after this video, don't watch anymore, open up VS Code and just start coding if statements and have a play. You will have so much fun. You can really have some fun with if statements. So actually do watch the rest of the videos, please do. But I'm just saying, have a play with if statements, right? Okay, so that marks the end of this video. Okay, thank you very much for watching. I really enjoyed putting it together. I'll see you in the next video. Bye-bye. Okay, so my VS Code is open up on match.py because we'll be looking at match statements, okay? This file is one of the supporting documentation files, so get them cloned down from GitHub. That is your cheat sheet, so you can always reference back to this whenever you see fit. But I have pulled this paragraph from Python's own website, and this explains exactly what a match statement is, but I will then demonstrate match statements because I don't think this is really kind of beginner proof. So structural pattern matching has been added in the form of a match statement and catch statements of patterns with associated actions. Patterns consist of sequences mapping primitive data types as well as class instances. Pattern matching enables programs to extract information from complex data types, branch on the structure of data, and apply specific actions based on different forms of data. Okay, so that is the official description of a match statement. But I'll show you what it all means. Okay, so a match statement takes an expression and compares its value to successive patterns given as one or more case blocks. So we have a class in this demo. So in the code examples here, I've got a class which we haven't touched on yet. I will be putting a class video together as part of this course, so don't get too caught up in the actual class itself. So let's look at this code. So I'll open up a terminal and a Python interpreter, but essentially let's look at this function. So it's HTTP error, and we're passing through an argument called status. Then we've got the match statement with a colon. So everything after that colon is the match statement, and everything after the case colon is a case to be matched or compared against. So we're passing status through to match, and then we're comparing the status against this case statement. Does it match? Yay or nay? Does it match? Yay or nay? So on and so forth. Now at the bottom here, we've got an underscore. Now that's a catch-all. If the previous 3 case blocks in this instance are not met, then this one will met. It's kind of the else statement in an if statement. So let's have a look. Let's get this in a terminal in a Python interpreter. py, and we'll dump that in here. Okay, so if I was to call HTTP error and pass through 400, we know that that will match. So the status, which is 400, will match this case statement. Okay, so if I do it again, pass through 404, found an error, which you'd expect because it's meeting that case statement. 418 is I'm a teapot, but if we were to pass through 401, something went wrong with the internet. That's the catch-all, okay? So that's kind of a very, very basic of a match statement. You could write that as an if statement, of course you could. So if status equals 400, so on and so forth. But match statements come into their own when you get a little bit more complex, and it takes a lot less code to get the same output. I'm all about less input, same output, or even more output. So this example is using the bar as an or statement. So if status is 400 or 401 or they're not allowed. 418 is I'm a teapot, and then a catch-all again. Okay, so let's go HTTP error, and this time we'll go 400, not allowed, because it's part of the case statement here. Again, if I go 403, it'll be exactly the same, because that is part of, this is kind of an or statement. So 400 or 401, 403. So if we put 418, that's matching the I'm a teapot, and then if you could put 500, it will say something went wrong with the internet. So that's a little bit more advanced than the first one. So we're stringing them along and using or. Patterns can look like unpacking assignments and can be used to bind variables. So point is XY tuple. So point here is a tuple of XY, okay? So let's copy that. Oh, sorry. There we go. I'm sharing a screen. I've got zoomed so far in that it becomes very difficult to highlight. So I do apologize. Let's dump that in there. Okay, so we've now got a new HTTP error function. And then we'll pass through, we'll call point tuple. Sorry, we'll add these to point tuple, okay? So we'll do the first one. So we go HTTP error tuple origin. Okay, so that's what we're doing there. So we're just changing the variable point tuple. So this is a 00. So that's meeting this. Okay. What we're then doing is we're actually assigning Y. So this is what the patterns can look like. Unpacking assignments can be used to bind variables. So we are binding, in this point, the index 1 of the tuple to variable Y, and then we've got variable X, and we're using that as in an F string. Okay, so let me show you what that means. If I'm butchering the explanation of this, then you can have a play outside of this video. So now if I call that again, what we've done here, so it'll be easier now to explain. So by passing through the tuple 0, 1, 2, 3 and calling it, we're then getting this printed out. And the reason we're getting this printed out is because we are assigning the first index, so which would be, in this case, in a tuple, it'd be 0 and 1. We're assigning that from point to a variable Y. Does that make sense? And in this case, we're assigning it to X. So X becomes the first point in the item in the tuple, and Y becomes the second item in the tuple. I may have butchered that as well, but let's have another go. So this will be assigning 1, 2, 3 to the variable X. So if I now call, there we go, X is 1, 2, 3. And the last one is XY. Okay, so that is matching this one here. So XY. So we're assigning the first item to X and the second one to Y. It's meeting this case, so it's printing out this F string, which is basically, I'm using placeholders to put the variables in. But again, you can look into that. I didn't go into that in any great detail in the string video, but that's just one way of handling strings with F strings and placeholders. Okay, so else we've got a catch-all, and it's a value error, not a point. Okay, so that is a little bit more advanced match statement. And lastly, we've got this one. Okay, so we will copy all of this to our interpreter. Okay, so we've got a class here, and we're using the We're importing data class from data class, and we're using that as a decorator. And essentially what that's doing is adding a whole bunch of methods to the class point. One of them is a dunder init. You got the repo, you got all of these different things. Don't worry about that. I've used that because it's made this class a lot more powerful without the need to actually code more. We'll talk about classes and whatnot in a future video. We've then got where is. So this is just a function. Again, we're pointing through point. We're passing through point as an argument, and then we're matching point against the different case statements. Okay, and you can see here we're actually calling the class point. So this is where match starts really coming into its own, because trying to do this in an if statement would be an absolute pain, and it will be very, very difficult to read. But essentially, the case statement is now a call on the point class. So if we now pass through, we'll call the where function and pass through the point class with 0, 0, we're getting origin, okay? Does that make sense? So we're calling the function, we're passing through an instance of the class with two arguments, 0 and 10. And it's just giving you all of it. It's matching the cases. We don't necessarily need to go through this, but what I've essentially given you here is a cheat sheet on match. It's very, very new. There's not many videos out there. I've probably just butchered match, but what you've got here is just some very, very basic to intermediate examples of how match statements are differentiated between if statements. Okay, so you can you are still matching. You're still checking a parameter or an argument against a case or a statement, and if it meets, then you do something, very much like an if statement in that regards, but you can do so much more. And when you get used to them, you can write some pretty complex match statements that are very easy to read, which is important. So okay, that's my video on match statements. I hope it was clear and concise. Please get the supporting documents from GitHub, and you can have a play in your own time. But the important one is this one here about classes, because you'll be using that quite a lot when you get more advanced. Thank you very, very much for watching. I hope you've enjoyed it. I hope it's been useful, and I'll see you in the next video. Thank you. Bye-bye. So my Visual Studio Code is open up on a loops.py because we're looking at for loops, we're looking at while loops today, so control flows. This file is part of the supporting documentation that you can clone down from GitHub, so please do have a look at that. And let's have a go of explaining what loops are, and then I'll give you some code examples that we can actually practice on. So Python's for statement iterates over items in a sequence. So it can be a list, a set, a tuple, a dictionary, or a string. And it iterates in the order in which they appear in the sequence, okay? So it'll iterate from left to right. If you were to then sort that list, for instance, whatever the result of the sort is, it would then iterate left to right, okay? So it's important to know that. So the built-in range function comes in really handy when you want to iterate over a sequence of numbers or a length of numbers or a length of an item, as it generates arithmetic progressions. So the range function can just take one integer, and that is the stop argument, okay? So it has a start, a stop, and a step. Okay, if you don't pass a start point, it will assume you mean 0. So the integer that you pass through to range is always the stop. If you pass through a third integer, that would be the step. Okay, so a start is the value of the start parameter. 0 if you fail to pass it through. Value is the stop, and the step is how many steps you want to do. I've got some examples of it that will kind of hit that one home. But then we've got a very basic example of a loop. So we're creating a list here. So it's got cat, it's got window, and then it's got defenstrate, okay? So we've got 3 items in the list, okay? For is what we use when we want to do a for loop. So we want to loop through each item in this expression, list in this case. You could use a string, but this is a list. So it's cat, window, defenstrate, okay? And then we're assigning it to a variable. Now that variable can be anything you want. It's a variable. So I thought when I first started coding in Python, or coding in general, that variable had to be W, because words starts with W. It doesn't. You can call that horse, house, parrot, Bobby, whatever you want. Every time you loop through that list, the item, the resulting item, is assigned to that variable. So it can be whatever you like, okay? So the first loop would be cat. W is assigned the string cat. So when we then print W, we're printing W, which is cat, and the length of that string, which is 3. So the result will be cat 3. The second loop would be window. So it would be window 6. And then you'll have defenestrate, which is, I think it's 10 or 11. So it'd be defenestrate and then the length of that string. So, okay, let's dump that into a Python interpreter. There we go. Dump that in there. There we go. So, like I say, cat 3, window 6, and it's 12. So the length was 12. Okay, so that's what we're doing there. Very, very basic. But the for loop, like I said at the top, you're just looping through. Every single loop, you're assigning what is found as an item or a character, or whatever the case may be. You're assigning it to a variable. You can then do something with that variable. You can print it. You can do a sum on a number. You can assign a variable to a key value pair in a dictionary, whatever you like. But you're doing a for loop. You can then nest an if statement in there and do something based on a condition. You can nest a match statement in there based on a case statement. The world is your oyster. Okay, so create a sample collection. So let's have users. What are we doing here? Create a dictionary called users. Okay, so we've got Quinn active, Eleanor inactive, John active. So this is a dictionary that contains users and their status, active or inactive. Okay, what we've then got is iterate over a copy. So we're making a copy of users. Okay, so we're making a copy of that dictionary. Remember, that was a method that we looked through in the dictionary video that I did a few videos ago. So for each user status, so this is how you work with dictionaries in a for loop. In a set or a tuple or a list or a character, for it's just one variable. But because we are looping through key value pairs, you need to express it in this way. So for each key value, in this case, we're just calling, you can call them a key value, you can call them user status in this case. I like to use key value. Doesn't matter. So for each user status, so user status, user status, user status, in a copy of users dictionary dot items. So these are the items, so each item in a dictionary. Okay, so what this expression here is basically saying that's one item. So we're looping through that, but we're assigning it to Quinn active, user status. Next item, Eleanor inactive. Next item, John active. I hope I'm kind of explaining what this means. This is a dictionary, so we loop for it slightly different. It's essentially what I'm saying. Then I've got an if statement. So we've got an if statement in here to say that if status, yeah, so that's the variable. So if status, in this case active, equals inactive, do something. In this case, we're using the delete function. This will actually delete user. So we're referencing the item by the keyword, which in this case will be Quinn. So if the status is inactive, well, that condition hasn't been met, so it won't do anything. So it does another loop. So we'll do another loop. The second loop, Eleanor, if status is inactive, delete it. So we will delete that because that condition was met. And then we'll do a third loop. If John is active, we won't do anything. So the resulting copy of users, because this is a copy of the dictionary, will just be two items, Quinn active, John active, okay? Okay, so if we go users, there we go. So that's exactly what we would have expected. So the inactive user has been deleted from the dictionary. That's what we just done. Okay, so create a new collection. So the new collection is an empty dictionary called active users. So this time we are going to do a for loop over users items. So this is the original dictionary. It's not a copy. And this time what we're doing is we're saying if they're active, then add the key into the empty dictionary with the value status. So that's how we're creating a new dictionary. Okay. So if doing the same for loop, except we're now checking that if the user is active. If the user is active, then we're creating a key value pair and we're adding it into the dictionary. That's how it works. If it finds the key, it will use assignment and it will assign the value to the key value pair. If it can't find the key, it will add a new key value pair. Okay, then we've got range. So let's have a little tinker. Okay, let's dump that in here. So for I in range 5, print I. What's that done? That's really, really helpful. Okay, so for I in range 5. So remember, we've just put one argument in the range function. Remember I said that the start would be assumed to be 0, and we haven't used a step. So the one integer we've passed through is the stop. So we've added 5. The first iteration of that range is always 0. Remember, we're using indices. So it's 0, 1, 2, 3, 4. That's 4 loops of the range function. It's where it's really helpful. Then what we can do is the start stop. Remember, so if we do 2 integers, it's start stop. If we do 3 integers, it will be 0, 10, 3. So let me walk you through this because this is interesting. So this is a start stop. So the first one is 5 and then it stops at 10. Remember, 10 would be 9 because if we did from 0 to 10, it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So because we're starting at 5, it's 5 to 9. Yeah, get that? And we're using the list function to then convert that range into a list. We've then got 0, 10, 3. So start at 0, finish at 9. So it's, finish at 10. So it's 0, 1, 2, 3, 4 through to 9. So yeah, we've got 10 integers, 0 to 9. But we're doing steps in 3. So it's only show every third step or every step of 3 in the range. So it starts at 0, then it's 1, 2, 3. Then it's 4, 5, 6, it's 7, 8, 9. So that's where the step function comes into it. And then you've got another example using negative integers, okay? So start at negative 10, finish at negative 100 in steps of 30. So it's 10, minus 10, so minus 20, 30, 40, minus 50, 60, 70, okay? It's really helpful to know. So we then have Mary had a little lamb, and we're assigning that as a list to variable A. And then we're saying for I, so copy. So let's see what we've just done there. Let's see if I can explain it. So for I, so remember that variable could be anything we want. So for Bobby in range len A, so that's the length of A. That would be 1, 2, 3, 4, 5. So remember we're adding len A into the range function. So that will be an integer of 5. So for range 5, so 0, 1, 2, 3, 4, they're the 5 in range, yeah? Print the variable, which will be Mary had a little lamb, followed by a integer. So sorry, so it's 0, 1, 2, 3, 4. So it's 0, and then we're returning the index 0 from A. That makes sense. So this is the list, and the 0 index is Mary. The 1 index is had, and so on and so forth. Have I got that in here? Well, I haven't. Let me open up lists and show you. There we go. That's what I wanted to show you. So indexing. I was losing myself there. Indexing is really, really helpful. There's a little diagram here of what it means to a string or a list. So the first item in the list is 0, index 0, 1, 2, 3, 4. So the first loop would be range 0. In the list would be Mary, and so on and so forth. Okay, so we don't need lists open. So that's what we've done there. And then we've got sum range 4. And that, sum range 4, 6. Okay, so what that's doing is 0 to 4. So it's 0, 1, 2, 3. So it's 0 plus 1 plus 2 plus 3 equals 6. That's what that's doing, okay? So it's sum itself is looping through the response of range 4 and then saying 0 plus 1 plus 2 plus 3 equals 6. That is what that's doing. So I've given you a whistle-stop tour of for loops or looping and conditional statements in Python. I hope it's been beneficial. spend some time doing it. So you now learn, if you've been following along with this course, we've gone through if statements, match statements. We're now going through for loops. We've gone through strings, lists, dictionaries, tuples, sets, and everything in between. Now you're starting to get enough tools in your toolbox to actually start coding. So please have a play, reference this document outside of this video and just start tinkering, start programming, okay? So for loops, very, very important, and it's hugely, hugely helpful when you're programming. So this marks the end of the video. I hope you've enjoyed it. I hope it's been useful, and I'll be seeing you in the next video. Thank you, bye-bye. Okay, so loop clauses today. We are looking at these now because we looked at loops in the last video. So loop clauses is a natural progression from that. Visual Studio Code is opened up on loopclauses.py, which is one of the files in the supporting documentation. So clone that down. It is a cheat sheet for you to use. So let's talk about what loop clauses are. So Python has a few statements and clauses that we can use in loops. They include break, continue, else, and pass. Okay, so loop statements may have an else clause. It is executed when the loop terminates through an exhaustion of an iterable, that's for a for loop, or when a condition becomes false with a while loop, but not when the loop is terminated by a break statement. So what does that mean? As a beginner, it's difficult to understand. So I've got some code examples to walk you through it, okay? So this is a little bit more complex in terms of a for loop, so I'll try and walk you through it, okay? So we'll put this in an interpreter as well, but this little statement here is for loop. So we know range, we're passing for a start and a stop. So for n in range 210 is the equivalent of saying for n in this little bad boy. So let's say it's a list. So 2, 3, 4, 5, 6, 7, 8, 9. So the first iterable is 2. So the first time it does a loop, it assigns 2 to the variable n. Keep that in your mind. The second for loop, so every time it does a loop, it then goes through this part of the code, okay? This part of the for loop, okay? So this is for x in range 2, so a starting point is 2, and the end point is a variable n, which we know is 2, because that's the first one. So range 2, 2 is the equivalent of a list that looks like that. It's got nothing in it, okay? So it hasn't got x becomes nothing, essentially. It's nothing, right? So there is nothing, there is no loop to be had. So when we then do this if statement, so if n modulus x equals 0, well, the comparison isn't there because you're comparing one against something that isn't there, equals 0. So that isn't false. That condition is not met. So it does else, print statement, I'm a prime number. The second loop is a 3. So this range becomes 2, 3. Okay? So it then compares that statement. If it's matches, so if modulus nx equals 0, then it prints this statement here. So n equals x, and it's got a little string of star, then it's it's floor division nx. Okay? So let's have that. We've learned all about floor division in numbers right at the start of this course, so you should understand what we're doing here. So copy, let's go terminal, new, and do this, and dump it in, and what do we have? There we go. So we expected 2 to be a prime number because the condition wasn't met. We expect 3 to be a prime number, okay? And then it hits 4, so the print statement is 4 equals 2 times 2. Okay, so it goes through. That's what that's doing. It's a basic kind of for loop, or it's for loop with a for loop with an if statement. So it's not basic at all. But we've got a little break statement here. So it prints out and then it breaks. Okay, so that for loop is finished. So it does the loop again. So that's what the break statement's doing. Okay, so continue statement. So for num in range 210, okay, so if num modulus 2 equals 2, then do something and it continues. So this will continue with the next loop. Okay, so this is another example. So it's just doing something slightly different. So found an even number or an odd number. Found an even, found an odd, found an even, found an odd. Right from the 2 through to 9. Then you've got the pass statement. Pass statements are really, really useful. When you're coding, you might write classes or functions that you need to call in another function, but you don't want it to do anything because you're not actually at that point of the code yet. You might be testing something. Pass just means that it does nothing. It doesn't break or anything like that. It just allows you to, I can call my pass class and it won't do anything. Okay, so this is an example of a function. You can add pass and I can call that function. So my pass def, okay, it doesn't do anything because it's just got a pass statement. If it didn't have the pass statement, then it'll come up with an error. Actually, it will show you in the text editor here that you can't do that. It just doesn't let you do it. So that is clause loops. Again, like with this course, I'm explaining what they are. I'm giving you some code examples, all that have been extrapolated from Python's own documentation for you to read up in your own time and have a tinker and kind of understand what I'm doing or what Python's doing. I have tweaked some of them. But yeah, that is loop clauses. I hope you've enjoyed this video. That is the end of this one. And I'll see you in the next video. Thank you. Bye-bye. Okay, modules today. So it won't take long to explain what modules are. So before I jump into it, my VS Code is open up in the modules.py file. You can reference this whenever you like. Look at it as your cheat sheet, but you can get the supporting docs from GitHub. So all of that will be in the description. Okay, so modules. So in Python, we're able to write a long program and save it as a module. This is known as creating a script. We are able to import modules across modules and into the Python interpreter. Right, so what you don't want to do is write a function numerous times. What's the best situation is to just write it once and do not repeat yourself. The reason for this is because if your function is incorrect and not working correctly, you need to debug it. And if you've got multiple occurrences of that function across your project, you need to debug all of them. What you need to do is create one function and import it as a module to your other application or other file in your project. So do not repeat yourself. Dry. That's what this is. You may see that a lot in your career. Python's standard library can be found here. They've got a whole bunch of modules and fancy stuff that you can import and take advantage of. Please look at that at your own time. We've got it here in modules. Have a look at this page and it talks about different modules. So import Fibbo, which is the Fibonacci module. There's loads and loads of different modules you can import, but we're not going to look at those today. We're going to look at our own that we've already created. So in the last video, we were looking at functions and we created a function called demofunc in the functions file. So that's a script that we can import. So if you look here, I've got from functions import demofunc. Now that will print out some gobbledygook, loads of twos because it's got some other functions in the file. But essentially with this line of code here will allow us to import that function so we can call it and pass it through to these functions. Let's get that. Open up a terminal, open up a interpreter, we dump it in there. Okay, so we've imported demofunc and yeah, it's printed out a load of twos because we've got some functions in there. Don't worry about that. It just now means that we can access demofunc. So we can say my int equals demofunc and we'll pass through 28. Okay, so my int now becomes 32 because that function is taking an integer, adding on 6 and then returning the new calculation. So we're expecting 32. But what we can do, we can now pass that through to my func1. So we can say my func will pass through my int. My func, what am I talking about? It's func1. Func1 my int. There we go. I do apologize. Okay, so you can see how we're importing a module and we're using that module to interact with other functions. Now we can import func1 into another module. Does that make sense? It's so important to make sure that your code is as dry as possible. Do not repeat yourself. It is really important. So we've then got func2. So func _2, is that right? Func _2. We won't use the demofunc this time because it's actually, yes, we will. We'll go my int, and this is given as the power of. So my int, in this case, it will be 32 to the power of 16. Oh wow, look at that. That's a big number. But That's a good explanation of modules. Okay, there, like I say, so Python's standard library can be found here on this page. So if you look here, I'll zoom in. Oh, it's not working. It's not liking that. Yeah, there you go. docs.python.org/3/tutorial/modules.html. That's where you'll find their standard library or documentation about their standard library. Their link to the library is, where is it? Let me crash that out. Oh, there we go. Can you see that on the screen? Yeah, docs.python.org/3-library. So actually, let's open that in the browser. There we go. So you've got a list of everything in here. Okay, so text position services. We've got date time, which is a great one. So you'd say import in the terminal py. So you'd say import JSON. You say import date time. Or you can go further and say from datetime import. I think there's delta. No, there isn't. There is a datetime actually. There you go. From datetime import datetime. So these are different functions and classes and stuff within those packages. So have a good read up on all of these. They're fantastic. Again, like the methods in lists and things like that. When you really understand this, it can save you lots and lots of time when you're coding. So that marks the end of this video. Hope you've enjoyed it. Hope it's been beneficial, and I'll see you in the next video. Thank you. Bye-bye. Okay, so we're nearing the end of this course now. We're looking at classes in the next video, and then we'll look at a small bit of programming, a little API that we'll write. That comes after this, which is all about exceptions and errors. So my VS Code is opened up on errors.py. This is your cheat sheet. You can clone this down from GitHub. Always reference back to this. It's really, really helpful as a programmer. So Python has at least two distinguishable kinds of errors. So you've got syntax and you've got exceptions. Okay. As a noob, you'll be getting a lot of syntax errors. You need to look at colons after functions and if statements and loops. You need to look at white space, loads and loads of problems. But that's where text editors are really, really helpful. So look at my text editor video, get one installed. We've got VS Code in this course. Syntax errors. As you become better, you'll know what the errors are, exceptions are, and you'll know how to handle them. So I've got all of the exceptions here. So you've got name of exception, description about what it actually means, okay? So we'll be having a look at some of these. We've already seen some of these during this course, but some at the bottom here, you've got type error, you've got name error, you've got zero division error, okay? So work through them when you've got a bit of time. But we've got here some examples of code that will be coming up with an error, okay? So if we go py here, dump in some code, this will be zero division because 10 times 1 over 0 is zero division. Raised when the second operator in a division is 0. You've got 4 plus spam multiplied by 3. Well, spam doesn't exist, so we've got a name error. If I put spam equals 2, it now exists, so we don't get the error. Then we've got a string plus integer. Doesn't like that, okay? But if we go 2 plus 2, it will like that. They're exceptions. So now we need to look at how we can handle exceptions. So we've got a little while loop here in my example. Let's get that dumped into the interpreter and see what's going on. So we've got a while loop. So while true, you do a try and except statement. So I haven't talked about try and except statements. You can read up on them on Python docs, but we've got one in here. So essentially it's trying to run a piece of code, but we accept that if any of these exceptions occur when running the code, we print this, okay? So this code could say anything really, but basically we're trying something, we've got a break clause there, and we're accepting if these exceptions occur, then we do something. So this is how you manage exceptions. So if we were to run a try and except on the code earlier, we could say if a zero division error occurs, then do something else. You can just print a fancy statement. Okay, so we put 5 in here, it won't have an error, okay? But if we were to find an error, then it will do this. It will print, oops, that was not a valid number. Try again. Okay, so then we've got a function. Try this fails. So we say this fails, division error. Okay, so 1/0, division error. But if we stick it in a try except statement and bung that in here, it's calling this fail. So try this fail. So we're calling the function and we're accepting 0 division error. Okay, and because we're accepting that, we can then say what happens. In this case, we're just doing a print statement. Handling runtime error, division by 0. Good. So the try and accept statement has an optional else clause which can be present, must follow an accept clause. It is useful for code that must be executed if the try clause does not raise an exception. Okay. So if a finally clause is present, the finally clause will execute at the last task before the try statement completes. The finally clause runs whether or not the try statement produces it as an exception. The following points discuss more complex cases when an exception occurs. So let's get this little function in here. Okay, what have we got? Let's see if I get it all on the screen. Okay, so we've got a function called divide and we're passing through 2 positional arguments, x and y. Okay, so it must have 2 arguments. So we're trying result equals x divided by y. So that is what we're trying. That's the little bit of code we're trying to run. But we're saying except if we receive a 0 division error, then we just print that. If we get type error, must be an int. If we else print result is result. Okay, so result equals, and then finally we print executing finally clause, tongue twister. So that will be printed anyway. Okay, so if we now pick up those commands and dump them in here, you should see an example. Oh, I didn't like that. Do apologize. Let's pick this up, copy, delete that. And let's dump them in. Okay, so the first example, divide 2, 1, the result is 2, okay? Because 1 is an integer above 0, so we don't get the 0. And what does it say? So the result is 2. So this actually, it tried it, okay? So result equals x over y. 2, 0, that is a 0 division error, so we're getting division by 0. Then we've got strings instead of integers. It's printing out must be an integer. So they're the 3 times we've called it. But if you noticed, every time we get an executing finally clause. That's because this is run every time it tries. Okay, so this is the finally clause, and that's what we're talking about in here. Okay, so that is a, let me just save the changes I made. That is a whistle stop tour of errors and exceptions. I hope this made sense. It's really, really helpful. You'll find a lot of this when you're reading other people's code, people that have been coding in Python a lot, you'll find a lot of this type of stuff. So try to understand it, read up on the exceptions on the Python website, understand what they do and what they are and how to handle them, and you'll be good to go. That's the end of this video. I'll see you in the next video where we will start to look at classes, or certainly I'll try to. Catch you later. Bye-bye. Okay, so looking forward to this one because classes are the cornerstone of OOP, or object-oriented programming in Python. Okay, we looked at functions a few videos ago, and I said that look at a function as a container. You add some script and what have you. When you save that container, you can call it and you give an input, you get an output. Okay, you can be doing some fancy stuff in the function, but essentially it's input and output. Class goes so much more further than that. It gives you the ability to bundle data and functions together. They are a powerhouse, okay? And unlike any other data type in Python, okay? So you can store data in dictionaries and lists and what have you, but classes give you the ability to store data and give it functionality at the same time. So if you look at VS Code on my screen here, I've got it open on classes.py, which is one of the files in the supporting documents that you can clone down from GitHub. This is your cheat sheet, so please do that. It's massively helpful when you're coding and looking back. Forget certain things, this could be your reference point, so please do. I've extrapolated a whole bunch of data from Python's own docs, which are in docs.python.org/3/tutorial/classes. They go into great depth about classes, objects, names, namespaces, inheritance, base classes, instance variables, class variables, and everything in between, okay? So a bit of bedtime reading for you. This course and this video is all about beginners and helping you get started so you can start tinkering and coding. So this is very much geared towards beginners, and I've just extrapolated what I think is what you need to know to start. So classes provide a means of bundling data and functionality together. Creating a new class creates a new type of object, allowing new instances of that type to be made. Python classes provide all the standard features of OOP. The class inheritance mechanism, that we'll look at soon, allows multiple base classes. A derived class can override any method of its base class or classes, and a method can call a method of its base class with the same name. That's all about inheritance. It frames it very, very well, but I'll walk you through that in a few minutes. Simplest form of a class definition looks like this. So you have a class keyword followed by class name, colon, then you have a bit of white space and all of this. Now these are your methods and class variables. Okay, so we'll look at that in a second. Like with a function, you must save or you must define a class before you can make or before it takes any effect. So let's look at some of my class examples here. Let's open up a terminal and a Python interpreter. So we'll dump this in the interpreter quickly so we've got my class available. So class keyword, then you've got my class, colon, and then you've got some of this. The first line here is text literal. I would urge you to add a text literal to all of your classes, because if you're looking back at a class that you wrote years ago or somebody else's code, they may, if it haven't got a text literal, there's no way of knowing what a class does without really doing a deep dive, where you can call a magic method called doc and it will tell you exactly what's going on. Mine's very simple, but you can put whatever you want in there. It could be 200 lines if you like. You then got a class variable, which is accessible to all instances of a class, which I'll give you an example of in a second. And then you got the f method, we're just calling it f, we can call it anything you like, but that is a method for this class that can be called, okay? And it will just return a string called hello world. So we can now call my class I and get back the integer 1, 2, 3, 4, 5. We can call f and get a function method, okay? And then we can call the magic method doc to get the string literal, okay? So you can call double underscore doc double underscore on any class and it will return the string literal if it has one. So let's go ahead and instantiate this class and assign it to a variable x. So the class is now instantiated and we can access it using a variable x. So again, we'll go x.i, I'll move my mouse, x.i, and we have access to 1, 2, 3, 4, 5, which is a class variable. Now, if we go x.f, but this time we have parentheses, it will bring hello world. The reason it's bringing back hello world is because we are passing through self. Let's talk about that. So we pass the method's instance object in as the first argument of all methods. So x.f, which is what we called here, is the equivalent of saying my class.f and then passing through x. Okay? Self has no special meaning in Python. The word self doesn't. It's just its normal convention to do so. So in this class, we'll pass through self. So that is, we're instantiating all of this to x, and then the first argument in the method is x itself. And that's how we can access that method and call that method. Okay. Hope that makes sense. But you can see we're doing it again here. So we're expanding on our class. Let's get that in here and talk about it. Text literal, no change, but we're now using a new magic method or dunder init method called init, and we're passing through self, which we do because we pass through the instance itself or the object itself, and then we're passing through a positional argument called myInt, and it has to be an integer. Okay, so if I didn't have this in there, you could pass through anything, but it won't like it because we're actually using an integer as a sum. So that's what that's doing. And within that method, we are assigning my integer to a instance variable called self.i. Okay, so that is only accessible to the instance itself. So whereas the first example, I was a class variable, this is an instance variable. And then with the f method, we're just doing a quick sum. So new variable equals, we get any integer that we're passing through as a keyword, positional argument, and we're doing a sum, which is the power of 3. So if we pass through 4, it's 4 times 4 times 4, which is 64, and we're returning new. So let's instantiate the class to x again. Now x.I is 4. It's not 1, 2, 3, 4, 5 now, because we passed 4 through as the positional argument. Okay. Now, if we go x.f is 64. Okay, so we're calling this method. It has access to self.I because we're passing self through as the instance. So x is accessible in f self.I. Does that make sense? I hope it does. So we're passing the instance through as the first positional argument. It's doing a sum and it's returning the new sum, which is 64. Good. Now let's talk about adding an attribute. So we can add an attribute to our instance called counter. It's not in the class. We're just adding this to the instance of the class. So now we have access to x.counter, which would be 1. But if we were to do a little while loop just on the sum, so while x.counter is under 1, we do something. And then, so we're changing counter to another number. And every loop, it just checks. Is it under 10? Is it under 10? Is it under 10? Oh, it's over 10 now, stop. That's what a while loop is doing. So essentially, I'll put a description here. So the first loop returns 2 because it's 1 multiplied by 2. And then x becomes 2. So it's 2 times 2 is 4. 4 times 2 is 8. 8 times 8 is 16. And at this point, it hits the loop and says, 16 is above 10. So stop. So the loop then stops. So the fifth loop does not happen. So we know that x is 16 down here. So if we print x, it'll be 16. But now we can delete that attribute of the instance x by using del. Now if we try and print it again, it just won't like it. Okay? It won't like it. But what we can say is attribute, or we can call it attribute 2. Oh, we didn't assign anything. Yeah, x attribute 2. And then we can find out, yeah, and we can do another sum on it. But then we can go del x dot attribute do, and that will delete it. And then we don't have it. Okay, so once we've instantiated a class, we can then add attributes, remove attributes. Really, really helpful. And you can't do that with dictionaries or anything like that. You can add data to dictionaries, and because they're mutable, you can change values and things like that. But with classes, you get so much more that you can tinker with. So now let's talk about, in a little bit more depth, instance variables. So you can actually understand it a little bit more. Let's create another class called dog. Now what we're doing is we're a class variable that's available to all, and then we've got instance variables that are only available to the instance. So when we instantiate the class, we will have access to a name and tricks variables. And then we've got a method called add trick, and we pass through a trick and it appends it to this list of the instance variable, not the class variable. Okay, so dog kind, the class variable is canine. So every instance of this class will have a variable called kind, and that will be equals to canine. So let's create an instance, assign it to D. Okay, an instance, I'm going to assign it to E. So D has the name Fido and E has the name Buddy, because we're passing through a positional argument called name. So you have to pass a string through. Actually, no, you don't. You can pass anything you like through, but we could do that. We could do that, and it has to be a string. Okay, so let's save that. So E kind, D.kind will be exactly the same. This is a class variable, but E.name will be Buddy, D.name will be Fido, because that is specific to the instance. Now we can go one step further, and we can assign a trick to D, and it'll be specific to D. And we can assign another trick to E, and all this is doing is taking that string and it's appending it to the instance list, which is an instance list is not a class list. If that was a class list and we added roll over and play dead, then both instances will have access to those tricks in this case. So we now put D, we don't want that. we want it down here, d.trick. You can see, sorry, d.trick. I was tricks, sorry. There we go. D.tricks, roll over, E.tricks, play dead. So we can then add another one to E. E.tricks, it's now got 2 in there. D.tricks, still got the 1, because we're only using instance variables. Okay, does that make more sense? So we're instantiating more than one class and we're tinkering with those instances of that class. So now let's talk about inheritance. Oh, let me just come back in here. I've made some changes. Inheritance. So a class can inherit from other classes. Okay, so base classes. Now it can inherit from numerous different base classes. Indeed, a base class can then inherit from another base class. Now this is really handy when you're trying to write clean code, because what you don't want is duplication of methods across numerous different classes. It's good to have a base class that has common attributes and methods that you can use elsewhere, and you can then inherit in a derived class from a base class. So think of it as kind of a tree. So you have a base class, which 2 classes can inherit from, 2 or more, and then so on and so on and so forth. Okay. So for instance, this example here, this dog class could inherit from the animal class, because a dog is an animal. You could have a class called cat that would also inherit from the animal class. Now that animal class could have a whole bunch of methods in there that are useful to derived classes. I've got another example here. So actually this is an example of a derived class. So you've got the class name and then you've got a bracket and all of the classes that is inheriting from. Okay, and then again, you then state the same you do on a normal class. But remember, a derived class can overwrite the methods of its inherited classes. For instance, the dog class might have a special method or a special way of handling the tail method that is different to a frog that doesn't have a tail or loses its tail when it goes from tadpole to frog. It's quite a good explanation of methods and overwriting them. Okay, so execution of a derived class definition proceeds the same as for a base class. When a class object is constructed, the base class is remembered. This is used for resolving attribute references. If a requested attribute is not found in the class, the search proceeds to look for that base class or in that base class. This rule is applied recursively if the base class itself is derived from another class. So it keeps looking and looking and looking recursively. Derived classes may extend or override methods from their base classes. Okay, so really, really, really helpful, and it allows you to write really clean code. Otherwise, you could have one class that is crazy long, and then you're duplicating some of those methods in another class that is crazy long. It's best to have 2 smaller classes, a base class that they both feed from. Okay, so I've got a couple of classes here that kind of walk you through that. So let's open and dump all that in my interpreter, and let's see if we can walk through this. Okay, so we've got mapping. That is our base class in this example. Private variable example. So check out _update. This is called name mangling. There's a bit about name mangling in Python's own docs, so have a look at that. That's the example actually they use in their own docs. So, but we don't necessarily need to talk about that in great detail at all in this explanation. It basically means that this update can appear where it appears in the class. It's done without regard of syntactical position. So normally you can only access certain variables because they appear above them. So, but because we're using name mangling, we can access update no matter where we put it. So do a deeper dive of that in Python docs. That's a bit beyond beginner level. So mapping's got a special method called init, and we've got items list and iterable as instance variables. We then got an update method. So for item in self iterable, so we have access to self iterable because it's an instance variable. We then append it to this empty list of the instance. Then we've got a class called mapping subclass, and which is a derived class, and a base class in this case is mapping, which is the class we've just talked about here. So this inherits from mapping. But you can see here, we're overwriting the update method. Okay, so although we've got it in here, this mapping subclass has actually got its own method called update, which will do its own thing. Okay, so don't worry about the actual functionality of the methods and what they're actually doing and the results. Don't worry about that. Just more or less just look at what we're actually doing here with the class and the inheritance. Okay, that's the whole point in it. So we will instantiate mapping subclass, and we'll call that, or we'll assign it to a variable called m. Okay, so we can then say m items list. Okay, it's the instance variable and it's an empty list. We will then call update. So in this case, we're calling update, and it's a list 1, 2, 3, and another one. These are values. Okay, so now we can quite simply add that, and it will create 1, these, 2 are 3 values. Okay, so what it's doing, it's creating what we're doing here. So okay, let's talk about the method and what we're doing, because it's actually quite confusing. Okay, so we've got 2 lists. It's got 1, 2, 3, and these are values. So what this update method is doing, it's for item in zip, and what we're doing, that is a built-in method called zip, and it basically zips 2 lists together to key value pairs. And then what we're doing is we are using self.items list to append item to the list that we just created in the instance variable. So that's why we've got a tuple, 1 these, 2 are, 3 values. That's why we've got that result. So, but if we were just calling the update method, we wouldn't get that, because all it's doing is it's iterating through what we're passing through. In this case, it's a list and a list, and it's just self items.append, and it's just appending the item. So we'd get a very different result if we weren't superseding the update method. Okay, I don't know if I've just butchered that inheritance explanation, but it's beginner's class, so hopefully that's given you enough to actually work. I mean, I've just used the zip method there, and I probably could have gone with a much more simple explanation, but if we were just using the base class update method, it would do one thing, but because we are actually overwriting that update method, we're doing something very, very different. Okay, so that is the end of this video. They are all of my code snippets that we've walked through. It's taken me nearly 20 minutes to do it. I hope I've done it justice. Again, I would just kind of reinforce what I was saying. This is very much a beginner's course, or a polishing up course, if you like, but read Python's own documentation, because it will give you a good rundown of everything in regards to everything we've gone through in this course, actually, because this is the last video about coding. The next video will actually be taking what we've learned throughout the course and just using it to write a short program. So thank you very much for watching this video. I've enjoyed putting it together. Hope you've enjoyed it, and I'll see you in the next video. Thank you. Bye-bye. So virtual environments today, they're an important part of any project. So we're open here on Python's own documentation on docs.python.org/3/tutorial/VENV, which is shorthand for virtual environment. Okay, so have a read of this in your own time. So virtual environments, why are they so important? Well, when you're programming, when you're a freelancer or a software engineer or developer, whatever the case may be, when you are throughout your career working on different projects, you'll soon realize that these projects can only function if they've got a whole list of different dependencies installed. Okay, they might be third-party packages in let's say a web framework called Django. You'd first have to install Django, and then let's say install Pillow or Requests or Django REST framework. You would have heard of these, some of these anyway. However, all of these third-party packages will have different versions. The reason they have different versions is because they are configured in a certain way to work alongside other packages such as Python. We've got Python 3.10 installed, or 3.10.2 installed on this project. Older projects might be using Python 2.7, for instance, and in which case the third-party packages that you're installing have to be able to work with those different dependencies. And this is where virtual environments come into it. Because if you were to install all of the dependencies globally, you will have a whole bunch of conflicts. So project 1 will need Python 2.7 and Django 1.8, for instance. And if you had all of those installed globally on your machine, well, you'd be in a spot of bother when trying to run project B that requires Python 3.10, for instance. So this is where virtual environments come in. You are able to create this little environment on your machine, install project dependencies within just that environment, and fire that up and work with that environment on your project. That way you can have one container for project 1 using dependency A, B, and C. You'll have another project, project B, using dependency X, Y, and Z. Okay? They are really, really helpful. Now, you can follow the walkthrough tutorial on the page that I'm on here using Python, or in my case, it would be py-m venv, and you can create a virtual environment like that. By all means, go ahead. It will create a virtual environment in the path tree that we're in the Visual Studio Code. However, I find using a third-party package called Virtual Env Wrapper to be a much better direction to go. So if you visit this here, which is, let's zoom in. So pypi.org/project/virtual env wrapper. Sorry, let's have a look again. Virtual env wrapper-win. That's the Windows version of this. What it does, it allows us to install this package globally, and then we can use commands such as make virtual environment and then name it. And it always saves and creates and configures a virtual environment in the same destination. Normally, users/yourname/env, and then you'll have a whole bunch of environments. Very, very easy to manage. Whereas when you use the Python alternative, this virtual environment is saved normally in the project that you're working in. And I just find Virtual Env Wrapper to be much, much easier to work with. So all you do is you copy that command. Because we've installed Python globally, we have access to pip, pip, new terminal. And all you need to do is pip install. Probably got that actually copied on my, so copy it there. There we have it. Same requirements already satisfied because I have already got that installed globally. So now what we'll do, we will go and use a command, make virtual env, and we'll call this Python -course. When I press enter, that'll go ahead and install or create a virtual environment on my machine in the folder C drive users Bobby/env, and then there'll be a folder in there called, or a directory in there called Python-course, and within there I'll have a whole bunch of different directory trees, and that's the environment. So that's the new path that we'll be using and installing packages into. And the reason I know it's working is because I've got parentheses followed by the name of the virtual env, and now that is ready for me to start installing things. So just a bit about a package manager called pip. They've got the PIPI library here, and you can easily find packages by a simple Google. Or you can go onto the main website and you can simply search here. So one normal, regular one that you'll see is Pillow. That allows you to work with images in Python. We've got, this is one that we'll be using in the next video. Sorry, requests I want, which is a library that allows us to make API calls. So in conjunction with other programs. You've got another one is Django REST framework. Oh, what have I done there? There you go, Django REST framework, a very, very famous third-party package that you can install that allows you to use Django, which is a web framework, just as a API backend, and then you can link the web framework with a front end such as React, for instance. Anyway, that is PYPI. That is a package manager, and we install from there using pip, which is a pip command. And let's actually install, I've already done virtual env wrapper. Let's go pip install requests. You see that? It's just behind my head there. But pip install requests, that will go about and that'll install requests into that environment. I might as well just open up the environment whilst we're here. C drive, users, Bobby, envs. What we got? Python course. Lovely. Okay, so this is the environment that we've got fired up. If you go into lib, site packages, a lot of these packages, can you see that very well? That's probably a little bit easier, right? A lot of these packages come straight out of the box, right? So if I'd have shown you this before installing requests, it might have looked a little bit different. But we've just installed requests. Can you see that? Go into requests, and this is the requests package. So it's a load of py files all working together. And all we need to do is now import requests as a module into our project, and we have full access to all of these files, all of the classes, functions, and everything else that's going on that's funky in that package we have access to if we install it into our project. It has come up with a command here saying you can upgrade pip. So all you need to do is just copy that part there. Can you see that? Let me make that. There we go. Copy that whole part there. And that will go ahead and it will update pip. And that's all you need to do. So that is virtual environments. I hope I did it justice. I hope you now understand why we actually use them. It's just a way of containing all the dependencies of your project in a nice little bubble on your machine, a nice little directory tree, so that you can access them willy-nilly. And look, I can deactivate that. So now I know the virtual environment is no longer working, and I can say work on demo. There is no virtual environment called demo. I think there is called demo 1. There you go. So I've got another virtual environment in there called demo 1. So I can turn one off and turn one on, turn one off, turn one on. And that's a good way of just working in different projects. So I won't drivel on any longer than I need to. That's the end of this video. Thanks for watching. I hope you've enjoyed it. I hope you found it useful. And I'll see you in the next video where we're designing and writing our very, very first program in this course. Thanks for watching. Bye-bye. Okay, so we're writing our first project today with everything we've learned throughout this course. It's opened up, my VS Code has opened up my project.py. You won't find that in the GitHub repository because I want to be coding this myself, so you can follow along with how I think and also see how poor I am at typing. Okay, so you'll be following along with this one. Hopefully it won't be too clunky, but the previous videos have been all prepared beforehand. This one hasn't, so hopefully you will see what I'm trying to do here. So the project will consist of us writing an API, which is an application programming interface. So our program will be talking to somebody else's program. In this case, it's the Chuck Norris API. So we'll make a request and it will respond a joke. Can't be too bad, right? So we will be using the requests library, which is something that we installed in the last video into our virtual env. That is a library specifically for this. So we use requests to make get, post, put, and delete requests to APIs and get a response. So that's what we're going to do. So if I open a terminal, if I go work on Python course, that will fire up the virtual environment because we've got the parentheses there. And if I now put pip freeze, that will list everything that's installed in that virtual environment. You can see here we've got requests because we installed that in the last video. So happy days. Let's close that down or minimize that. We don't need it. So if you watch the modules video, should I say, you'll know that we can now import requests because it's in our virtual environment. So it's in our extended directory tree. We will also import, no, we'll leave it as requests. So I'm going to be using classes because I want to show you a base class in the real world and a derived class. So we use a base class to make the request, to make the call. And I'll use the derived class to actually build the request itself and then maybe call the function, the method in the base class. So that's what we'll try and do. We'll be using an if statement maybe, or a match statement. We'll be writing or raising type errors or exceptions and using f string. So we'll be basically using a lot of the stuff we've learned. Not everything, but so you'll be able to see that I'm using certain things that I know from my Python skills and actually writing a program with it. So without further ado, let's jump straight into it. So let's write a class and we'll call this API call. Nice and simple. And we use a text literal to say base class to make a basic API call with requests. Oh, happy days. And then what we'll do is, so the method we'll use, this will kind of be a global method that will be we can use this across numerous APIs. That's why we're putting in a base class. So this one just needs to be a method that allows us to call, and we'll pass through self. So we'll pass through the instance of itself. And what we need to have posted through would be the method. So get, post, put, delete. So method. And also the endpoint, the API. So API, let's go URL. Okay. So first thing we want to do is do a if statement. We'll do an if statement. So if method equals method lower. So we don't know if there's going to be uppercase or not. Equals get. Then we'll do something. So get, we will make the request itself. So r.requests.get, and we'll pass through API URL. Okay, nice and easy. Now we could use an else statement. I'll raise exceptions later on. This won't be something that you can use. You would have to change this if you're going to use this in your own program, because we need to capture the post, the put, the delete methods also. So we're not going to use an else or an if else or anything like that to save time. But we will now do a match on the response. So with requests, you get a status that you can tap into, or a status code that you can use to check whether or not the API call was a success. A success is 200 or 201, 202. Depends on the API. But we want to check to make sure that the status code of the API response is 200. And if it is, then we'll return. And if not, we'll raise a type error. Okay, so match r.status code. There we go. And we'll have a case statement for this. And that will be 200. We'll have a little bar. 201. This is basically saying or, and in which case we want to return, and let's just return a string. No, it will be r.json, and I think it comes back as text. Obviously, this is all, you could change this as value. So this particular API it returns a response JSON. You can then get the specific text for this called value. Now, obviously, that's not going to be the same on every API, but let's assume it is for this example. And then we'll have another case statement which catches everything else, and we'll say raise type error. We'll just say API error, shall we? So if it doesn't come back as 200, it would just raise API error. Not the best description, but you can imagine you can use different exceptions and different strings and what have you, and it can just basically work through the different exceptions. So this is the cool method that we'll be using in our derived class. So we now put class, and we'll call this Chuck Norris, and we will be putting API call in there because this is the base class for the derived class. We'll have another text literal, and we'll say this is the Chuck Norris API. Doesn't really matter for this example, but you can add a description. Okay, so we want a class, because this is specific for Chuck Norris, we can have a class variable called URL. And what I'll do, I'll put HTTPS, and this is API.chucknorris.io. That's not going to work. No, it's .io /jokes/random category equals. Okay, and then what we'll do, we'll construct a API URL by using a placeholder. Okay, and I'll show you what that means in a second. Categories equals, and we'll just have animal. And also they have one called dev as well. They have more, but we'll keep it as dev and animal. And then we will, I'm not going to add that. Now we will have dunder in it. So in it, we'll pass through self as we normally do. And we'll also pass through category, because this will allow us to instantiate the class with animal or dev. Okay. So we'll have self dot category equals category. There we go. And then now you could have if not self dot category in categories. Do you know what we'll write it? Cat self dot category, sorry. So this is if instance variable is not in class variable categories, then we can then raise type error cat not options animal dev. Okay, so that's just the type error that will be shown. Now we'll have def, and we'll have this one called get, and we'll pass through self. So this is the get request for the derived class. You can also have a post request, put request. Well, it depends on what you want to do and how you want to construct it. But essentially, the first thing we want to do here is we want to construct the API URL. So we want to use an F string with placeholders. And the first placeholder will be self.url, because that is the class variable we've got here. Okay. The second one, we want to pass through the category that we're passing through. So it's self.category. Okay. And then what we can do is return self.call. This is the base class function. This one here. You can see we need a pass through method, an API URL. So we'll go, these are positional arguments. We don't need to use keywords. So we can put get, or you can even put get like that, because we're actually using the lower method. And then we'll have API URL. We don't need to use self, because this is just a variable that we're using within the function there, or in the method. And is that coming through? Value return.json. Yeah, that just return the string. So that'll be just string. That looks like it could work. Okay, so I'm gonna go ahead and test that. Hopefully that'll work. So let's go terminal, and what we'll do, we'll go work on Python course. That'll fire up the virtual environment. I know that because we've got parentheses followed by the name of the virtual environment. Now we'll fire up our Python interpreter. So we can use the modules import. So import projects or project, which is this file here. Okay, so we're importing project into the Python interpreter. And now what we can do is we can go API call dot doc API call not found. Oh, so it'd be project dot API call dot doc. There we go. So that we're using the dunder doc method there to just print out the text literal. Actually, what we'll do is import from. It doesn't matter. It doesn't matter. Okay, so we now have access to these classes in our Python interpreter. So now what we'll do, we will instantiate Chuck Norris to a variable C. So if we go project Chuck Norris, and remember we need to pass through a category. So if I just put A, it'll come through and say, look, category options animal dev, because we've got the type error. But if we were to put through animal, we've now got C. So I can say C dot the get. Do I call it get? Yeah, there we go. Get, and we'll pass through. Actually, we don't need to pass through anything. Will this work? Happy days, it works. So we just called the get method. The get method has constructed a URL, and then it's called the self call method from the base class. Pass through get, your new URL, and then it's gone around and followed this match statement. So it's matched. We used an if statement for the actual get request. We could have used a match statement, and then we used a match statement with a case statement to look at the status code. If the status code matches all of this, then we get the value keyword from the JSON response, and then we just return it into the Python interpreter. So what is that joke? What have we got? They say curiosity killed the cat. This is false. Chuck Norris killed the cat. Every single one of them. Okay, and then you can do it again. Oh, is it always coming back for the same? Oh no, so it's the same one the first time, and then it made another call. So Chuck Norris once rode a 9-foot grizzly bear through an automatic car wash instead of taking a shower. Okay, should we make one more? Oh, it's the same one. It keeps coming up with the same one. There we go. So that works. That is the project. You can see, if we go back to the code here, you could easily just create a new class. And we could call this NASA. Yeah, we can make an API call to the NASA API. We would just need to change the URL. We'd change the categories if that was indeed the case. If there wasn't categories, if there was a few different sorts of categories. I know in a NASA API, they've got different cameras and what have you. So you would just configure the class slightly different. But what won't change, or possibly won't change, is the call method in here. And if it was to change slightly, you could overwrite it or extend it in the derived class. Okay, so I'm really happy with that. That actually did work really, really well. So that is the end of this course. We've written our first project. It's an API call to the Chuck Norris API. It worked really well. We're using classes, base classes, derived classes, match statements, if statements. We're using strings. We're using all sorts of stuff. We're using lists here. You could even go one step further, and you can maybe do a random pick of all of the different categories. So you always got a randomized response rather than animal. So when you're instantiating it, you won't get similar jokes. But hopefully you can see now from this project that the world is your oyster. Just play. You've spent the last few hours going through this course. I've showed you the absolute basics, what I think are the fundamentals of understanding Python. Okay, take what you've learned, write some programs. That is the best possible way that you can learn how to code in Python. Also, always reference back to this cheat sheet. I'll say it again. You can clone this down from my GitHub repository. This is your cheat sheet. Please, please, please use it. In 2 years' time, or 2 months' time, you might look back and go, oh, what was that about dictionaries? What was that about tuples? Why can't I do X, Y, and Z? What are the methods? Whatever the case may be. You've got a cheat sheet, so clone it down. It's for you. I made it for you. So, like I say, this is the last video. This is the end of the course. I have thoroughly enjoyed putting it together. I truly hope that you've enjoyed watching it. Please, please, please get in touch if you have any questions whatsoever. Thank you very much for watching, and I will see you in the next course. Thank you. Bye-bye.